Oh. Streaming one. Oh. Almost. What is that? That's so weird. Oh. So it's working on YouTube. I think it's working on Twitch. Oh, that's so weird. Oh well. I think it's working. Yeah, I'll just start and it should be fine. Okay. Do. Okay, cool. We're on. Okay, awesome. This is my first multi-stream. So it's going on Twitch and YouTube. So hello Twitch, hello YouTube. I'm just setting a few more things up here. Okay. Streaming, and last thing is chat. Awesome. Okay. Okay. No. Oh no, it is working. Okay. Okay. No, it is working. All right. I'm happy. Let's get started. All right. Hello. Hello. We're going to be making a VR rhythm game today. I've been thinking about and hoping to make this thing for a while now, and it'll be good to just get stuck into it. I haven't done a demo yet, so I'm not sure exactly how this is going to go. I got some ideas of how it's going to work. You may have guessed that this is this is inspired by quite directly by a very popular VR rhythm game called Beat Saber. If you haven't played it, the idea is that you have like a lightsaber essentially. You sort of go. I'll quickly show you what it sort of looks like. So we've got an idea of the sort of thing we're creating. Let's type in Beat Saber. So essentially, you're in VR. You have like a lightsaber, and you gotta hit these little targets that are coming at you. Too loud. Okay, so there's these targets coming at you. They're coming at you to the beat. This is quite a fast song. We'll probably start off quite simply and slowly, and then we'll sort of get the fundamentals there, and then we'll work in how we're gonna sort of map the beats, and we'll get a few different songs in there, and yeah, it's gonna be fun. So what I thought I'd do first is I'll just go over the plan. Oh, I just turn this off. I'll just go over the plan of what we'll be creating and what steps, and then we'll get started. All right, now just grab my pen. Okay, that's working. All right, so we're gonna like any good knockoff, you just gotta have to change the name just a little bit. So we'll call this one Rhythm. Was it Rhythm Blade? Rhythm Blade. Our absolutely unique rhythm game. Okay, and the steps. Okay, so a lot of the first steps are really going to be similar to any rhythm game, right? Like if we talk about the difference between Beat Saber and something like Guitar Hero, it's just the inputs. Kind of like the Guitar Hero, you got these little buttons that you press. Beat Saber, you just got to move your arms around and you sort of hit these colliders. So the first stuff we're going to do is just kind of rhythm game related, and we'll look into first of all we'll look into where we're gonna source our music from. So we'll just go. First of all, we're gonna get a song. Get song. Okay, we're gonna use a public domain. But this just means that we can really use this song for all kinds of things. I'll have to double check. I'm not sure if you can make money off a public domain song. I don't know if you could sell it without talking to the author, but we can certainly use it for projects and post it on. I think we can repost it online and that sort of thing. Like, demos, that sort of thing. It's fairly safe. People release music as public domain, generally saying like, yeah, like play around with it. So we'll look at how to do that. Now, the second thing we're going to do is we're going to look at. We'll just make sure that we can get a good beats from the song. So we'll call it just beat detection. Because what we're going to do is we're going to have if we think about it, how we're going to sort of be creating this project, we'll be using the Unity editor, and the idea will be to have the song start at a certain point, and then we want to, at after a certain amount of time, we'll then be generating the targets to the beat of the song. So we'll need to come up with a way of making sure that we have the beat of the song. We'll look into that. The third thing I want to do is just get the Unity project running. So we'll just get the Unity project, and we'll also look at how to import the song, how to assign the beats per minute to that particular song, this sort of thing, and yeah, get the audio playing in Unity. The next thing I want to do is look into how we're gonna get this target system working, and I'm not sure exactly how that's gonna work yet. We'll have to play around with it. We'll just start really simple. We'll start really simple with a few targets and how we're gonna be able to say like, oh yes, you hit that target and that sort of thing. It's gonna be a bit interesting having them, because you want the targets to get to a certain point, to a beat, and you want to display them before that beat. So we'll do, it'll be a little bit interesting there. We'll just call it target generation, or target generator. And along with the target generator, will really be we'll do a bit of thinking of how we're gonna have the targets displayed before the beat and arriving to a certain point, on the beat. We'll look into that as well. The next thing we're gonna look at is once we have the targets coming, we're gonna somehow have to say like, oh, is there something hitting it? If you have a VR controller, are you hitting the target? So we'll also do that. We'll just do collision. And then once we have that, we'll also want to show like a score. So we'll have like a scoring system. So collision and scoring. Okay, and finally, the last thing we're going to do is look at how we want to implement it in VR. And I'm still a little bit undecided as to how to do this. The thing about it seems to be that the thing about setting up a project in Unity, if we set up a project as a VR project, it means when you hit the play button, it'll sort of start up the VR thing. And maybe we want that. Maybe we want to do as much as we can before we have the headset and everything, really understand our systems and that before we have these extra inputs and that sort of thing. So we'll do VR very last. And yeah, I'm still a little bit undecided as to whether to have the VR like implementation as a separate Unity project. Like for example, we'll have our like I'll just show you quickly. Like, this is how we might do it. I'm still a little bit undecided, but we could have like a rhythm blade project. Rhythm blade, right? And then from there, could have a VR implementation of it. I mean, it might be interesting to see if we could use a. Oh, I don't have one on me, but see if we. Oh no, one of these. Yeah, see if you could use like a mobile device as like your input. You know, using AR Core or AR Kit might be a bit of fun. So you know, this is how we might do it. We might do a VR implementation and an AR something like that. Yeah, but we'll see how we go when we get there. We'll at least look into the VR side of things first. So VR implementation. Alrighty. So the first thing we're going to do is we're just going to look into getting a song going. Okay. I'm just going to double check that this streaming's working. Okay, I think we're looking good. Okay, now there's a few different ways we can get public domain songs. Let's start off. What happens if we just type this in? We just go public domain songs. I think there's a few different links, a few different websites. This is the one I was using before. I'm sure that a lot of them are quite good. But we're just going to use this one, Free Music Archive. A ton of public domain songs. Okay. This might even have a bit of information about public domain songs. Maybe we have a quick look into it. Might be worth reading. Creative Commons. Okay, so on top of traditional copyright. So this is what sort of we've got to keep in mind when sharing our projects, that sort of thing, because we're using other people's content. Okay. Okay, so it looks like there's a little bit of variance to the licenses. So, for example, just by quickly scanning this, it looks like we can say there's sort of like you can use it, but you have to attribute it. So you have to say where it came from. Share alike. Okay, I think this means, okay, so the first one means Creative Commons looks like with the attribution, as long as you explain where it came from, you can sort of do what you want with it, with a song. You can even make money off it. It looks like if it's share alike, that means that whatever projects you create with it, you can still make money off it, but people are allowed to use that project and make their own things with it. And you can't stop them from doing that. Okay, and it looks like non-commercial. I believe that's sort of self-explanatory. You can use it for whatever you want, but you're not allowed to make money off it. No derivatives, and that means that you're not allowed to chop it up and use it for a different purpose, I believe. Yeah. Anyway, you can read this yourself if you're really wanting to get into it. Free Music Archive / license guides. We're just gonna go ahead and find some songs. Now, I'll recommend using electronic music, because electronic music tends to have a absolute beats throughout the whole song, because they're generally using like this production software. Which will be really helpful for us if we want to just type in a BPM into our game engine, and it just it'll just line up. So let's go ahead. Let's go ahead and look for some electronic music. Okay, let's see. Go genres electronic. Okay, cool. There's subgenres. What do we feel like? Something that's dancey is important. Also because it's like a dance track, we kind of want it to have a bit of variance. We want it to, start slow and then go like really big, that sort of thing. Would be cool. So I don't know. House can be pretty cool, although I'm not sure if house will have the variance that we're looking for. Let's try one of these. Let's see. Let's pop my headphones on. Okay. It's good. It's good. I just feel like we're wanting a bit of like we want something that changes up a bit, quite a lot. Like, oh, I'm like this, and then change it up to a different, like a few different sections. I'm just gonna try a few more here. Okay, so we'll remember that Ultra Cat. That's pretty good. Funk the floor. Let's try Big Beat. I'm not sure what that is. That's pretty cool. Interesting. That's really nice sound. Okay. Let's try out another one of this guy's. Gosh. Sort of. Okay, we'll remember that one. I'll try one more. And then we'll lock it in. I'll try one more genre, and then we'll I liked how that genre had these sort of like gaps, and then the drops. That could be a lot of fun to make a dance song to. Let's see. If we go to electronic again. Oh, techno. Techno might be it. Let's try techno. Where's techno? Here we go. All right. Let's see. Bio unit / meter. Truckin'. That sounds cool. It's a little bit, yeah. Sort of want something a bit more, more of a track. Okay, I know I said one more, but I feel like there's still at least there's got to be one more in here. That's gonna fit. So we want something a bit uppity, a bit happy. I wonder if you can search by like mood. That would be cool. Okay, maybe not. What's jungle? I don't know what that is. Maybe dubstep. Maybe dubstep will be the trick. Here we go. Foo up jump. That sounds like what we want. Okay. Yeah, I kind of like this one. I just want to listen to it through a bit. I feel like there's a break coming. Yeah, look, I'm happy with this one. I'm gonna lock it in for now. All right. I'm gonna grab this other one as well. I thought this other one was good. I think it was let's see. Gosh. What was it? Funk the Floor. Let's just try this one. I'm also gonna download this one. And one more. I know. I keep saying one more. Oh. Just try this one last one. And nothing. Okay. All right. We'll just be happy with what we got. Fruit Up Jump and what was the other one? Funk the Floor. Cool bananas. Okay, so now that we've got our songs, I'm gonna like. There's probably a few different ways we can get the BPM. One of the simplest ways would be to just go. If we look up tap tempo, there'll be some online BPM tool where we simply play the song and then tap as it plays, and it'll give us a BPM. So for example, if I go like, that's going to give us some sort of beat, and it looks like most likely it's going to be 130. Almost certainly. I just want to try one little thing out in case it works. I haven't really tried it out before. I'm just going to use this program, and I feel like they might have a BPM like detector, which would be like a really nice algorithm, which would just like give us a number. Let's see if this works. Okay, so if I go view, I'm not sure, effect, maybe not, analyze, beat finder, oh yeah, maybe, analyze beat finder, okay, this might do it, huh, oh that literally found the beats, that's interesting. Oh, that is interesting. I'm not sure yet, but yeah, it's possible. It's possible that we might be able to, if we were able to use this beat finder, and then have it spit out the values like into a JSON file or something, we might be able to import that into a game engine, and then you'd be able to use songs that don't have a fixed beat, which would be really cool. Anyway, let's see if there is a So okay, so I don't think Audacity has a beat like a BPM detector. I'll just double check that really quickly. BPM detector. Okay, so you can download one. Look, that's fine. That's fine because we've got a technique. We can just use our tap tempo. That's probably the simplest way to do it. Okay. Yeah, let's just do it. If it ain't broke, don't fix it. Right, so we know that Funk the Floor is 130 BPM. And what is this other one? Fruit Up Jump. Okay, I just want to double check this is the same tempo the whole way through. Okay, this is looking like it's most likely 140. Let's double check that. Yeah. Awesome. Okay, so I'm just gonna put that in a name. Okay, so we'll just go. I'll just go to funk the floor 130 BPM. 130 BPM. And foo up jump we'll just put in as 140 BPM. Alrighty. Sweet as. Sometimes it's encoded, although it doesn't look like it is. Yeah. Okay, so sometimes they have the data encoded in the actual MP3 file itself, but these don't, which is cool. We've found a way of getting them. Alrighty, so now we've got that done. Let's go ahead and start our Unity project. Okay, let's clear that out. Alrighty, so I'm just going to start a new Unity project. Let's go to Unity Hub. I'm just going to call this one a rhythm. Was it Rhythm Blade? Yeah, I haven't even thought about how the blade's going to work in this, but we'll start it. It's a good name. We'll create a new project, call it Rhythm Blade. Rhythm Blade. Put in parts just R, encoding. Okay. So, the first thing we're going to do in our project is just have it. Alright, first of all, really simply, we'll import our audio files and just have them play. That can be our first step. The next step is we'll create some scriptable objects, which means we'll be able to assign some information to the songs, like the BPM, and also like things like the artist and that sort of thing, so it could like show up when people press play on the when people are playing the game. So after that we're going to look at the targets, and that's something I haven't really thought about too much. But yeah, anyway, we'll get started with the audio. So create a new folder, just call it audio. Go ahead and import our downloads into that folder. Take a little minute. Alright. I think that worked. Oh, what the hell? Sorry, it's getting a little weird thing happening with the chat at the moment. Oh, it's crashed. Gosh. One moment. Sorry, I just gotta do this this chat thing. Restream chat. Okay, let's see if that works. All right. I think that's working. So this weird thing, like if I click on this window, it doesn't respond. Not sure what's going on there. Hopefully, if there's anyone in the chat, can you just write a message? I'd love to see if this is working or not. Because at the moment I'm streaming both Twitch and YouTube, And I'm not sure if chat's coming through. Anyway, be all right. I'll just pop out the regular chat. You should be able to see it. Okay, that's cool. All right. Apologies for that. Let's get back into it. Okay. So we've imported our audio. First thing we're going to do is just have the audio play. So I'll go ahead and create a script for that. Or no, we don't. No, we don't even need a script for that. Let's say just go game objects. Let's call this audio player. We're going to attach an audio source. Set the audio clip to UltraCat funk the floor, and have it play on awake. That's by default. It just means as soon as we hit play in Unity, it should start playing. Perfect. Sounds good. Okay, now we have that playing. Oh yeah, let's go ahead and create some. We'll call them scriptural objects. These are objects that'll hold the audio, and they'll also hold some metadata like the BPM, that sort of thing. So we're going to create 2 folders here. We'll create a folder called scripts. We'll also create a folder called scriptable objects, or just SO. So the scripts will be the code that we'll write to create these types, and then we'll create instances of them using SO. So let's go ahead and do that. So I'm just going to create a script, and maybe I'll call it. Let's call it audio object. Okay. And all we're going to do is we're just going to make this one will inherit from scriptable object. So it goes inherit from scriptable object. We'll create an asset menu so that we're able to instantiate it in the Unity editor. And let's see, we just let's see if I just create. I'm not sure if I need to type in like what the menu name of that's going to be. We'll see how it goes. Anyway, all this is going to have is a public audio clip. Audio clip. Okay, audio clip. And for now, let's just have an integer, which will be our BPM. Int BPM. Okay. So I'm wondering, because I haven't set the create asset menu. I'm not sure how this will show up. Let's see, so if we go to create, oh, okay, yeah. So it's just popped up at the top. Audio object. That's the one we want. I'm just going to call this one funk the floor. And for the audio clip, we'll just pass in funk the floor. And the BPM was 130. And we'll do the same for, I can't remember what the other song was called, like Up and Up or something. Foo up jump. Okay, foo up jump. Okay, and that one's 140. So foo up jump. BPM can be 140. Alrighty. So now we have the audio. I want to make sure that the audio is playing at the right BPM. How are we going to do that? See, I haven't really thought this through. So first of all, we need to find the amount of time between beats, which is it's just the inverse of a BPM, right? So for example, let's see, where's my pen at? If we have something that's all right, let's start really simple, right? Let's start something at 60 BPM. Okay, that means in 1 minute it'll play 60. It'll have 60 beats, right? Well, what's the duration? What's the time between each beat? It would just be point. What is it? Sorry, I'm just figuring out, because what we really are going to need to do is we're going to need to convert it to seconds first, and then we'll work in seconds. Okay, so first of all, we've got to convert it to seconds. So 60 BPM times 60 times 60. Should be able to work that out. 60 times 60. Let's see. 6 times 0 is 0. 60 times 60 is 1200, right? 1200. I think, yeah, I'm pretty sure that's right. No, it's not right, is it? It's not right at all. It's 3600. 6 times 6 is 36 and 2 zeros. So it's 3600. Okay. So if it's 60 BPM, you multiply it by 60 to get seconds per beats per second. That's not right, is it? Divided by 60? Divided by 60, don't you? Divided by 60. 60 divided by... No, that's not right either. Okay. I'm just gonna go ahead and look this up. We're gonna do a bit of investigating. BPM to seconds. Let's see, each beat. Divide by 60 by the BPM marking. Oh no, it is right. It is divided by 60. It is divided by 60. Right. This makes sense. Okay. bear with me here, guys. We'll get there together. Okay, so let's see. If we have something that's 60 BPM divided by 60, well, that's 1 BPS, one beat per second. That makes sense. 60 divided by 60 is 1. And then if it was, say, 120 BPM divided by 60, well, that's going to equal a 0.5, right? 120. No. Yeah. Oh, wait a minute. Yeah. Okay. So that's 120 over 60. That's going to equal 2 beats every second. That makes sense. Equals 2 BPS. Okay. So now we've got the formula to convert beats per minute to beats per second. Now all we need to do is invert that to get the duration of each beat, right? And all we do to invert a number is we just go let's see, we just say duration equals 1 over BPS. Which will give which makes sense, right? So if it's 2 beats every second, so in 1 second 2 beats happen, then each beat will be 0.5 seconds long. And then if you go, oh, okay, well 1 out of 2 is 0.5. So then we got our amount of seconds that each beat is. Okay, so our formula is, we're getting there. Okay, so our formula is beats duration equals 1 over BPM divided by 60. Okay, so first of all, we convert it to seconds, and then we invert it to get the duration. So let's go ahead and do that. So what we want to do. Well, all right. This is how, because we're going to start talking about the markets, how that's sort of going to work. And what I'm thinking is, what we can do is, let's just create an object. For starters, let's just create an object every beat, right? We'll create an object every beat and just have it like move off in some direction. That makes sense. Okay, so let's go ahead and create a script for our, I'm just going to call this target mover. This will be target mover. And really simply, all it's going to do is it's going to, when the object, this will be attached to each target, which will be the things we're hidden, and it'll just move in some direction every time it's created, whenever it's created. So we'll just have a public float speed. Okay, and I'm gonna do something a little bit weird here. This is just because these targets are gonna be created. They're gonna be created, by code. And maybe we want to change the speed at runtime, and we want that change to be saved when we stop the play mode of Unity. So there's a really nice way we can do that. Is we can create what we'll just call a float variable. And this will be another scriptable object. Float variable. And this is literally, oh wait, that was cool, honestly. Yeah, nice. Okay, so this is literally, it's literally just a float value. And what that means is we can say our target mover will have a public float variable. We'll call it speed. And so, you see where this is going. We can create a scriptable object, and we'll be able to change that at runtime, and the changes will be saved when we stop the play button. All right, so now when it's created, let's update. So we want to move. If a player's facing forward, we'll imagine the target's in front of the player. So it might be easier. If the player's facing forward and the target's in front of the player, and you want the target moving towards the player, so you want the target moving backwards. All right, so we just go transform.translate. Vector3 dot forward times. Or first of all, we'll create a float speed. I'll call it translation. Now that's going to equal speed dot value times time dot delta time, right? So, just to take into account, this is going to happen every frame, and so, if the frame was, just a really quick frame, you only want it to move a little bit. So this is what sort of like scales. Delta time will scale our speed by that amount. All right. So once we have that, that's looking good. Oh yeah. We want to say negative translation, right? Because you want to move backwards. At the moment, it's moving forwards. So now let's get moving backwards. Okay. In a float variable, I just want to make sure that in the menu name, I'm just going to have this. I'll just call this one variables. And it'll be called float variable by default. Okay. So let's have a look at how we're going to put all that together. What I'm going to do is I'll go into SO, which is short for scriptable object. I'll just call this one speed variable for now. Maybe we want the objects to move at 1 meter per second, 1 unit per second. And now we can go ahead and create our prefab for the target. So I'll just create a new folder, call it prefabs. And what I'm going to do is I'm going to, let's see, go into the scene, create a new game object. Just call it call it target. Target. We're going to attach a script with the target mover. In the speed, we'll just attach our speed variable. And now the last thing we want to do is, let's see, oh yeah, create a like some sort of shape. We'll just make a cube for now, which will be just a child of the target. I might make it a bit smaller as well. That's 10 centimeters. It's a bit too small. Maybe a foot wide, foot long. Coming at you. Yeah. For now, we'll make it. Make it 30 centimeters. Alrighty. So let's see if make sure the chat's working. Yeah. Cool bananas. So, So. Next thing we want to do is save this target as a prefab. All we need to do is drag it into the prefabs folder. And now we just need a target generator, and we also need a like we really want our objects, our scripts to do only one thing. So I want the target generator to generate the targets, and then we'll have another script called like the music. I don't know. We'll maybe be like the beat event. Beat event. Beat event caller. Beat event. Like, have an event happen every beat. I don't know what to call it. Beat. Beat actor. Something like that. Anyway, first of all, we'll create our target generator. It's really simply, it's just going to have a public. Game object. Public game object target, and we'll have a public void generate target. Just go game object dot instantiate target to do at wherever the target generator is. So just I believe if we leave this blank, it'll be local. It'll be relative to the parent. So if I just go transform like this, it'll make it wherever the target generator is, it'll be at that spot. I believe that's how that'll work. I'm not sure if this is working. I'm just looking at the stream and it looks like it's frozen. Oh no, it's working. Oh yeah. Huh. Okay. Yeah, no, you're not. It's all good. Okay. So we're generating. Yeah, this is literally what our target generator is going to do. Just keep it really simple for now, and then we'll have a beat. No, what is it? It's because we got to have an object that's gonna every time we get a beat, it's gonna generate an event. And it's also going to be responsible for playing the audio. I'll just call, for now, I'll just call it audio player. Okay, and so yeah, this is really simple. It's going to need an audio object. And it's going to have let's say for now it'll start playing. It's also going to need an audio source. No, it's not. Okay. I'm really wanting to. This is something I'm just practicing, like I'm getting used to this new thing of like, what do you call it? It's a separation of concerns, or essentially thinking about things in terms of data and in terms of if we're able to have this audio player not know what an audio source is and not know what a target generator is, then we're going to have a far more flexible architecture. So what we're going to do is instead of saying audio source dot play, we'll have an event saying on play, and we'll attach the audio source to it. So for example, if we use Unity engine dot events, and we'll just have a Unity event, public Unity event on play, and we'll have another Unity event on beat. Okay, so let's say void. So for now we'll play the song as soon as the game starts. So say on play dot invoke, and we're also going to need to remember when the thing started. We're also going to need to work out the beat duration. Okay, so we'll say we have a float start time. Okay, and we'll just say start time equals time dot elapse, time dot time maybe. The time at the beginning of frame in seconds since the start of the game. Perfect. Okay. Now, let's work out beat duration. Okay, float beat duration. Beat duration, remembering our algorithm, our beat duration equals 1 over, make sure it's a float, 1 over audio object dot BPM divided by 60. And again, I'm just making sure these are floats. We don't want any integer division. Okay, once we have the beat duration, now we're able to start working out if a beat's passed. Okay, so let's have another float. We'll call it last beat. Float last beat, and when the game starts, last beat will also equal the current time. Okay. Now void update. Okay, so now we can say if the beat, we'll just have a little, I'll do a little diagram what the plan is. Okay, so imagine that we got this, right? We got our, let's see, Let's get the chat up. Okay, let's say we've got a timeline, right? So we've got song start of the song, maybe the end of the song, and then I don't know. It's a really slow song, so there's like only 4 beats or something in it. What we want to do is we want to say, well, in each frame, how long since the last beat? Okay, so we'll have a last beat time. Last beat time. We'll have a current time. Okay, and then we'll have a delta time, a little delta sign. Delta time equals current minus last. If that makes sense. Okay, so what we can say is if delta time is greater than the beat duration, right? Because this here is beat duration. Well, this is beat duration. And if this delta time is greater than the beat duration, so it's here, then we've got a beat. And then if we have a beat, we can say, then we can have our on-beat event will be invoked. Now the only thing I'm thinking about here is, I just want to give you an example. We want to be short. So we just say, I'll just make this clear. If delta t is greater than beat duration, on beat invoke. Okay, we can do that sort of thing. Now, one thing we want to be careful about is, let's say for example we have a start here, an end here, right, and a beats here. Update. If we say, oh, here's a beat, right? Beat detected. Okay, beat on beat there. Well, if we say, oh, okay, well now the new start of the next beat is here, or last beat here is here, then whatever that difference is between when the actual beat was and when we found out there was a beat, that will be an error. And as the song goes on, our beat detected will get later and later and later from the actual beats. So really we want to calculate the beat, calculate the last beat time, which is really easy. The last beat time is just a number of beats times beat duration. No, sorry. Yeah, no, that's right. So beat duration, if there's been 0 beats, it'll be here would be, the beat duration is like 0.2 seconds, it'll be 0.2, here would be 0.4, etc. So instead of setting our last beat to whatever the current time is, we'll actually calculate the last beat based on beat duration and number of beats. All right, let's give that a go. Okay. So we'll have an int beat count, and whenever we start, beat count is 0. Okay, and then we'll have another function on beat, and when we get a beat, let's just work out what we just talked about. Let's just say last beat equals beat duration times beat count times beat count, and we want to increment beat count. This is a little bit ambiguous. This is one way of saying the increment beat count before making the calculation, but we might as well just be more explicit. Beat count plus. Okay. So now we've calculated our last beat. Now we also want to say on beat on invoke. And now to check whether the beats are triggered, we say if time minus last beat is greater than, I'll just call this, put this in a variable, float dt equals time minus last beat. If dt is greater than beat duration on beat. Okay, so yeah, so we've got our function on beat, which we'll call our event on beat, and then yeah, we'll see how that goes. Okay, well, I also just want to log. I want to log how it's doing, just so we can keep an eye on what's sort of going on. Log delta time dt, and then what we'll also do is we'll log beat detected. So we'll have log beat detected. Okay. This will be enough for us to start. Okay, let's see. Let's delete this target prefab from the scene. well, we've already got our audio prefab objects. I'm going to remove the audio source for now. And we'll just put our audio player. For our audio objects, I'll just pass in func floor. And let's just see how that goes. Now we're not gonna hear anything because we're just looking at the numbers for now. Which is looking sensible. What I'm gonna do is I'm gonna instead of printing out this delta sign, when we start, I'm just gonna print out the beat duration and the log the BPM and the beat duration. BPM plus plus audio object.bpm plus let's see, I think that'll work. Beat duration plus beat duration. Okay. Yeah, and I'll comment out this delta sign for now. Let's see how that goes. So beat duration should be about 0.5, I think. Yeah, 0.4. Cool. Okay. Now here's the test. Let's have it play the audio, and then might be able to hear the see if these beat detectors are coming along, these log messages are coming along to the beat. I'm going to create a child object just to keep things sort of modular. Call it audio source. And we'll just have to punch in an audio source there. Okay, for now I'm just gonna pass in the song. This is not a great way of doing it, because if we want to change the song, we'll have to change it on the audio player and the audio source. But we'll look into that later. Okay. Now we say audio play.onPlay. Let's see, we go to audio source on play, audio source dot play. Easy as. And we just make sure the audio source doesn't automatically play, so it doesn't play on awake. Alright, let's see if we can hear this beat. That looks pretty good. That looks really good. The real test will be 2 minutes into the track, because that'll be when it's had enough time if there's any errors, for those errors to have accumulated. But I think this is working quite well. Yeah, that's working quite well. Okay, so we'll just leave that playing for now. What's the next? Oh yeah, so now we just need to say every beat, let's generate an object. Let's generate a target. That'll be cool, because we'll be able to visualize. We'll be able to see the beats in the scene. So just turn off play mode for now. Okay, and now let's create our target generator. I'm gonna put it. I kind of want the origin to be the 0, 0, 0. So I'm gonna put the target generator 10 meters in front of the player. 10 on the z-axis, and maybe might as well have it. Should we have it up? No, probably leave it on the ground. Probably easiest to have it on the ground, and then we'll work from there. Okay, so pass in a target generator, target prefab. Now, our audio, so this is what I mean by a modular sort of approach, right? On beat, we'll have our target generator dot generate target. Now, the reason why this approach is so cool is that because everything's just using these events, what it means is that later on, let's say we have a producer or someone who's like, yeah, no, man, look, it's working really well, but I want you to do like a particle effect when a target's generated or something like that. Well, then we just simply add another listener for this event. We just go, add a listener. So it really keeps things nice and easy for us. Let's go ahead and see what this looks like. There we go, that's pretty cool. Okay, now I'm gonna have, this is playing every beat. Maybe want it to be every 4 beats, like boom, 2, 3, 4, boom, 2, 3, 4, boom, 2, 3, 4. That sort of thing. Okay, so I like the target generator. This is where we got to sort of think about how are we going to design it? How are we going to have it sort of, how are we going to have this thing sort of, how do you say? How do we want to feed in information and have our target generator only do something every 4th beat? So what I might do, I like the audio player only having an on beat. I kind of think that's complex enough for one class. So for now, let's have our target generator. Instead of this generate target, let's have a public void, we'll call it beat handler. Okay, all that means is that it's saying, let me know if a beat's happened. Okay, and see what, we might as well go into this. At the moment, our audio player is keeping track of the beat count. Now we could get the target generator to also keep track of the beat count, but then we're just asking for problems down the road, you know? Like you can just imagine how things could get messy that way. I'm gonna close this. I don't think this is working. Okay. So it's gonna get messy down the road if we just keep it that way. So what I'm thinking we could do instead is we could pass arguments through the events. So I'm just gonna go ahead and create a new folder. Just call this folder utility, and we're just gonna create some Unity event types where we're able to pass through data to them. So let's go Unity events. Okay, this is gonna hold a bunch of different classes. It's gonna use Unity engine.events. The only reason we need to do this is so that things are serialized, so that we're able to see them in the inspector and they get saved. This is just gonna be let's see, using system as well. System. Okay, so we're just gonna say serializable. This will be a public class int event. It's going to inherit from Unity event. Now what we can do here is we can pass in a type of int, which means this will be an event where you need to pass an integer into it, essentially. Okay, and then so for our audio player, instead of this just being a generic Unity event on beat, it's going to be an int event, which means that on beat, when we invoke it, it's saying, okay, you want me to invoke on beat, but I need to pass an integer in there, so let's pass in beat count. Okay, so now every beat it'll pass in the amount of which beat it is. Yeah, it won't pass in the very first beat of the song. Is that a problem? I kind of don't like it. For some reason I feel like because the very first when the song starts playing there is a beat there, I feel like it should call on beat for the very first beat. So what we'll do is we'll have beat count increment after the first beat, and then on start I'll just call this on play. I'm just going to move everything from the generic Unity start function into our on play. And what we'll do is we'll just call, after we call on play, we'll call on beat. Okay. So all that means is on the very first beat we'll create an object there. Okay, so now our target generator can have a beat handler which has an int beat count. Yeah, we just call it beat count. Okay, so it'll be 0 for the first one, etc., etc. Okay, so now I'm just trying to remember what they're called. You know, like in terms of music, there's different what do you call it? You got whole beats, which is every 4, half beats, which is every 2 beats, and then quarter beats is every 1 beat. Yeah. Okay. So okay, so we'll have just for now, we might move this around a bit later, but for now we're just gonna have a public void whole beat handler be a public void half beat handler, and we'll also have a quarter beat. Okay, just to test this out. Alright. So for now, we'll pop this instantiate into, or generate target. I should have just left that. I'll leave that there. We'll generate a target every whole beat. And to work this out, we just simply say if beat count modulus 4 is equal to 0, if the beat count is divisible by 4, you know, so 0, 4, 8, 12, that sort of thing, then we'll call a whole beat handler. Okay, and then we'll do the same for divisible by 2. And we'll go half beat handler. And really, like, I could be a real smart ass and say if it's divisible by 1. But that's really not necessary. Sometimes I do this sort of thing because it kind of makes it a bit readable. It kind of says every 4 beats, every 2 beats, every 1 beat. You know, I might leave it in there, even though this if statement will return true for any integer you pass it. It still kind of makes it like that's so easy to read. Anyway, that's good. So we can go ahead and test that out. Now in our audio player, we're gonna have a different on beat here. And then have the target generator dot target generator. Here we go. So now we've got all these static events, which is just kind of like if you want to call something or if you want to set it to enabled or not. But when you're passing a parameter through to a function, you have this dynamic int. So even though, let's see, okay, so even though you notice that this function occurs is twice in this menu, here in this static parameter, we could pass in fixed value, right? So every time this function is called, pass in the number 4. But we don't want to do that. We want to pass in whatever the function, whatever the event's sending whatever parameter the event's sending through. So then we use this dynamic int beat handler. Just make sure that we do that. Okay, so now we should hopefully be getting it every 4th beat. See if that works. Oh, nope. That's not it at all. What have we done there? Let's see. Let's close this off. Whoops. Made a mistake somewhere. Audio player. Okay. I made one little. I've noticed I've made one little mistake. The last beat is really start time plus beat duration times beat count. I know that won't really matter at this point, but it's got to be offset from whenever the song started. Okay, let's just check this. Debug delta time. Wait a minute, when we hit play, we should be able to read out the... It should be telling us a bit, like, the parameters if they're correct. It's not doing that. Oh, I know. I know. On play. Okay, so the problem that's occurring now is that it's because I didn't press play. I think the beat duration was 0, so it's always gonna be beat duration is always gonna be delta time will always be greater than the beat duration. So what I'm gonna do is I'm gonna have another bool. I'm just gonna have a bool is playing, and that's gonna be equal false by default. So just say if it's not true that it's playing, I'll return. Okay, and then on play is playing equals true. Alrighty. So let's give that a go. Like, it seems to be working. It seems like there's a bit of a delay. Okay. Well, we know what I'm thinking. This is how I'm envisioning what's happened here. So you have an artist who's in there, making some music. Oh, it sounds great. It's all to this 130 BPM. And then they go to release it, and then they say, wait a minute. At the moment, it's going from like 0 to this, as in like as soon as the minute someone presses play, it's that first beat. And maybe you don't want that. Maybe you want like a little bit of room at the beginning of the song. So some sort of like I don't know what you call it, like a delay. Like a tiny delay. If we go back to Audacity and we have a look at this audio file, I wonder if I can just Audacity. Open with, I'm just going to see if I can open this with Audacity, it would be nice. Audacity, maybe x86. It's Audacity. Program files, x86, Audacity. Oh, am I blind? It is, it's right there. Oh my god. Okay. See if this works. Oh, it does, nice. Okay, so if I go ahead and zoom in here, right to the beginning, see this? I'm wondering if this is it. I'm wondering if this is why we're getting our delay. What's that? That's 0. That's like the first beat. It's 0.09 seconds or 09. That's really the first beat. Like right there, right? Maybe we'll call the first beat as being there. We'll say 0.097 would be the delay to the first beat. I'm wondering if that's why we're getting a slight error. Let's go ahead and add a parameter. We'll try it out. We'll add a parameter to our audio object, and this will be called public float start delay. And now with our audio player, okay, when you press play, play the music. This is interesting. Because when you press play, start playing the music, but don't start doing your calculations until after that start delay. Okay, so we'll have another one. I'll have another void on after delay. After start delay. After start delay. Let's call it after start delay. Okay, so I almost need like a... I feel like this audio player, instead of playing or not playing, it almost needs a state. This is at least where I'm going with this. I'm thinking it should have a state. It should be like not playing at all. in pre-play, we'll call it pre-play, or like you know, playing essentially, and then we could switch the state in our update. That's what I'm gonna do. Okay, so I have a public enum let's call it play state. Go ahead, not playing, pre-play, and is playing, or just playing. Okay, pre-playing. Yeah. Oh yeah, not playing pre-play, and on. You know what? Okay, public state. Stop. That's easier to read. Stop, pre-play, and play. Okay. So now we can have a public play state. Oh wait, this shouldn't be public. Let's have a play state. State. Play state equals play state dot stop by default. Okay. So now on play, we'll begin the pre-play essentially. So play state equals play state dot pre-play. This will get a bit interesting. So we have a start time. Now we have a pre-play start time. Pre-play start time. And so we want to trigger after start. We want to trigger the real deal only after that pre-play. Okay, so everything that we've been talking about is once that first beat starts. Okay, so on play, just set the play state to pre-play, and now we'll only go to playing if the elapsed time is greater than that pre-play duration. Okay, so void check play started. I need better names for this. Someone in the chat. By the way, if there's anyone in the chat, could you please send a message? Because I haven't got any messages yet. I'm wondering if I'm doing the first ever YouTube and Twitch stream. I'm not sure if the chat's working. Anyway, might not be working. I'm not sure. Okay, so where was I? We'll go back to checking if the play has started. I don't really like that. So you have pre-play state, and then you have, I don't know, like real play state or something. Check, I don't know what you call it. You know what I mean? Like we have this section here. That's pre-play. I like the name pre-play. And then we got this section, which would be maybe check song started. All right. So we'll have pre-play and song play. I like that. Pre-play and song play. Pre-play and song play. So pre-play is before the song, and song play is that first beat. Okay, so we have a void check song play. Okay, and in check song play, we just say if time minus we'll do this in another variable. So we have a float dt equals time minus pre-play start time. And just to avoid any confusion, we'll have a start play. We'll have a song play start time. Okay, pre-play start time, song play start time. If dt is greater than audio object dot start delay, then let's switch our state to song play. Play state equals play state dot song play. Okay. Now, Now we just do a little inner update. We'll switch through our play state. Play state. Okay, if the case is that it's in play state dot stop, then we'll just return. Case play state dot pre-play, then we'll check if the song started. Song play and then break. Oh, in fact, we probably should just break for the stop case as well. Okay. Okay, so now if it's not playing at all in update, then we'll just break. If it's in pre-play, we'll check if the song's playing, and then we'll have another function. We'll have another function called check beat. Check beat. Check for beat. Check for beat. And in check for beat is simply this one. It's going to make this much simpler update function. Okay. Now case play state dot song play check for beat. Alrighty. It's looking good. Okay, this is sort of making sense now. Now last beat is going to equal song play start time. So now when we switch from, I'm just going to move these things around a little bit. Move the update just under the start, nice and easy to read. Okay, now when we switch from pre-play to song play, we need to set our song play start time. Now, song play start time, like we could say, oh, just equals current time, but again, with that thing of, because our update function might be happening a little bit after that song play start time, we really want to calculate it using our, remember our song starts playing at the pre-play start time plus the delay. We know that, right? So whatever time the song started, plus this delay, which is 0.097, I believe. Yeah, we'll just use that one. Okay. So, where are we? Pre-play start time. Okay, so on play state equals pre-play. We'll have a Unity event on pre-play. Let's be really explicit. I don't think we're going to need any event for the start time. That's really just an event for the first beat. So we'll leave that one commented out. So on pre-play is when our song will start playing, and we'll set the pre-play start time. So pre-play start time equals time dot time. Okay, and now check for song play. Okay, so if we do go into song play, then our song play start time equals pre-play start time play start time plus plus audio object dot start delay. Okay, I'm gonna log a message. Log song has started. Okay. I'm just realizing that this once it's started, we really should just use all this, right? Like okay, let's see. Okay, so once the song started, we should really, like, instead of waiting for an update to check to check whether the song. What am I saying? Okay, so we have our pre-play. All right, so let's talk through. Let's take a step back. What's happening here? We have a first of all, it starts off at a stop state, right? So it's not playing at all. Then we say on play. On play, then we switch our state to play state. We'll call the on pre-play dot invoke, which will start the audio playing, and whatever other effects we want to do. And we also want to say the pre-play start time equals the current time. Okay, so that's good. Okay, and then now if we're in this pre-play state, let's go ahead and check whether our song's actually started. And how we work that out is we say, well, however long the amount of time since the pre-play started. If that's greater than the start delay, then that means our song has started. And in that case, we're going to do all of our song start stuff. Okay, play state equals song play state. We're going to log the BPM. All this stuff can go in on play. Like beat duration, that can go in on play. Song has started. Let's see, it's just a bit messy. Song play start time. That looks good. Last beat equals the current time. Let's see. Beat count is 0. That's right. Song is started, and then we'll call for the first beat. Okay, let's go ahead and give this a go. Okay, so we're going to have to re-hook up that audio player, the audio source rather. Audio source dot play. And then on beat, we're going to generate a cube for each beat. Oh, and also we need to go back into our audio objects and set that pre-play duration, which is 0.097, I believe. Let's go double check that. 0.097 seconds is about right. Yeah, that's about right. Perfect. See how it goes. It's not really working, is it? What I might do is instead of starting when the game starts, I'm not sure if that's the best idea. Like maybe because there's a bunch of things that happen when the game starts. Maybe it needs to be called like I don't know, maybe like a little bit after the game starts. So I'm just gonna say I have a floater. I'll just call it auto start delay. Right? And let's say equals 1. So we'll just have the game start 1 second after. Have the song start 1 second after the game starts. Okay. So let's see. Well, let's go. In the case of a stop play state, so we're not going to call anything in the stop method. And in case of a play stop state, then what we're going to need to do is we're going to need to say check auto start really. So let's have a void check auto start. Okay. So this one's really easy. If time.time is greater than auto start delay, then on play. It really should just be called play. It's not really an event if it's internal. Okay, so if the current time is greater than that auto start delay, and this is only going to be called from the stop state, then maybe things will be a bit more in sync. I'm not sure if they will. We'll find out. Let's see. Better, much better. Much better. That's really interesting. They seem to be coming out just a little bit too quickly. So I'm gonna change this start delay to let's see, instead of 0.09, let's change it to 0.1. Let's change it to 0.2, see what that's like. That's better. It could be. This could be because it takes a little bit of time for the audio source to actually start playing. That could be the case. I'm not sure. I wonder if an audio source has like an event, like an on play started. Anyway, this method's good enough for us to get the ball rolling. Okay. So, what have we got so far? We've got our targets coming out at the same time. Okay, this is where things are gonna get really weird. Because, let's see, how we can do this. What we really want, and maybe we don't want to think about it yet, but what we really want, we don't want the targets to generate on the beat. We want them to arrive at a position on the beat. Am I trying to sync the entire thing to one backing track? Ross, I'm not sure what you mean. I'm working with this one track, and the idea is to sync it through that track, right? And the idea is for it also to be flexible. I think I get what you mean. So, for example, this Funk the Floor song, this one's got a BPM and a delay from when that one started. But let's say we've got this other song which has a different BPM and it'll have a different start delay. So hopefully we can use different tracks and be able to automatically have it sync up to them. That's answering the question. Okay. So here's an interesting one. What do we want to do next? Because really what we should be thinking about is how to get if you imagine your Beat Sabering or something, and you have the targets coming at you, and you want them to get exactly to this point on the beat. We really should work that out. I think, yeah. It'll be worth it for us to just work that out for now. This might take a few minutes to sort of like get the algorithm going, but it'll be worth it. Let's have a think about this. So at the moment they're being generated on the beat. We know the beat duration. So what we really want is, let's see. Let's say that we want the beats to start arriving, the beats to start being generated like let's say 8 beats before the song starts playing, right? So the song starts playing, okay. So we sort of got to work our way backwards. Let's have a look at a timeline. That might be helpful. Sort of very much a feel like sometimes I'm a visual sort of thinker. Let's have a look. So, synced up. Let's see, we got a timeline. There's a nice timeline. Let's say we got a song that starts at, say, 5 seconds. So the song starts here. Okay, and then just for simplicity, we'll have a beat every second. And maybe we've generated some map or some algorithm or some way of generating the beats. What we want is we want to calculate what's 2 beats in the past, or how X amount of beats in the past, and then we want to trigger those. We want to trigger those target generations. Generate the target. However many beats in the past. This is interesting. Might start just by coding something up and seeing how it goes, and then we'll sort of Just so sometimes it's better to just start coding it, see how everything's falling into place, and then then we'll go from there. Okay, so let's have a look at what we got so far. So far we got this audio play, which is taking into account our pre-roll, our pre-play, and all that sort of thing. I'm just gonna duplicate this, and we'll just go ahead and I'll just call this audio player pre-roll. And hopefully this will be an audio player that's able to get the what we want it to do is we want it to, let's say, okay. So I know I'm jumping back and forth a bit here, just sort of getting it going in my head. Okay, so we'll start off with a public integer. Public int, we'll call it pre-roll beat count. Okay, so in other words, how many beats do you want us to start triggering this on beat in before the song actually starts? Okay. Okay, so once we have our pre-roll beat count, we can calculate when our first beat's going to be. Okay, so let's have a look at how that's working at the moment. So when we play, I'm just going to comment this out for now. We're going to create a new state. We're going to create a new state called, should we create a new state? Maybe not. Maybe we won't need to. Okay. So when we hit the play button, what we want to do is we want to start our beat generation, and then if the beat count is greater than, oh, this is so weird. Okay. Okay, I think I'm starting to get it. Okay. Wait, let's jump back to our... This is really weird. We'll jump back to our drawing. What we want to do, alright, so we know our beat duration. That's something we can work out. How long is a beat? We can work that out. Okay, so beat duration is X. So what are our variables? Well, we start with our pre-roll beat count. Okay, and that's going to equal, let's say it'll equal 8, something like that. And then we've also got our beat duration. For real simplicity, we'll just say that's going to equal 0.5. Now, using these two variables, we can work out one where this is. We can work out one where our first beat is, beat 0. beat 0, I don't know, generation or something like that. Okay, and then we also need to work out, remember that we've got this delay in when the song starts to from when the song starts to a delay let's get this right. From a delay between when the song starts and when we hear the first beat in the song. And that's how what's it called? Pre-play or song delay. I think, yeah, it's our audio object or song delay, right? So song delay equals 0.2, something like that. Now we can work this out. So we can say our pre-roll beat count is our beat duration is 0.5, which means our actual song should start playing about, let's say, yeah, I know I've written song start here. Yeah, song start is really going to be about here, right? Because there's going to be a little gap. Going to be a little gap there between when we hear that first beat and when we want to actually trigger the song playing. Okay, so how we work out this distance between the first beat being generated, the first target being generated, and when that song starts playing, is that's going to be beat count times beat duration will get us to here, right? Beat count times duration, because that's 1, 2, 3, and 4, and then, you know, whatever the duration is, and then we subtract song delay will be our start playing the song. Okay, so we're saying song play start playing. Okay, that's going to equal pre-roll beat count. I said really long variable names. I'm just going to say PBC times BD, beat duration, times BD, minus SD, minus song delay. Okay? So pre-roll beat count times beat duration gets us to here, and we subtract song delay, which will get us to here. And that'll be the time that the song should start playing. Okay. This is sort of starting to come together. Sort of coming together. Okay. So, let's see. So where do we start? So first of all, we start with our play. We still want that auto start. I feel like that auto start did sort of help out a bit of the problems we were having with I don't know, if you call something from the start function, it seemed like there was a bit too much else going on for it to be spot on. For the Unity to start everything spot on. So I like that. Okay, so on play, first of all, what do we know? We're gonna need to call on beat. Okay, this is what's changed a bit, because we're calling on beat. However many, let's say pre-roll beat count, however many beats before we actually hear the beat. So I really should call it something else. I really should call it on pre-beat. Yeah, this is what I should call it. I should call it on pre-beat. On pre-beat, because it's not the beat. It's on the it's calling, like, it'll call beat 0 8 beats before we actually hear beat 0. We'll call it on pre-beat. On pre-roll beat. Like that. On pre-roll beat. Okay, so when we start playing, on pre-roll beat, roll beat, dot invoke. Okay, and then we pass in beat count. Oh, right. Okay, yeah, okay. On pre-roll beat. Okay. So instead of song play start time, everything's a little bit inverted now. Instead of song play start time, we have a pre-roll start time, which is different. It's different. Okay, so I'm going to rename this Pre-roll start time. I know this is so topsy-turvy. This is what it's the process. Okay, so we have a pre-roll start time, and we have a song play start time. Song play start time. That'll be when we actually play the track, not when we get the first beat. Okay, pre-roll start time, song play to start time, beat duration, last beat, they're both good. Beat count, they're both good. Okay. This auto start delay should be public. Might want to change that in the editor. Okay, Unity. Okay, I'm gonna rename this to on song play, which will factor in that delay. All right. Pre-roll start time, song play start time. Okay, so if we're in a state, sometimes I like to do this, just take a step back and keep walking through the code. Sort of makes sense. Okay, so if we're in a state of stop state, which is the default, we'll check auto start. Auto start will happen if time is greater than auto start delay, and then we're going to play. That's good. We're going to have a play state called pre-roll instead of pre-roll, pre-play. Okay. Stop, pre-roll, and play. That'll be our three states. Sometimes you just got to close it and open it again. Okay. Now what's this? Unreachable code. How's that unreachable? Pre-roll. Oh, I think that's a mistake. I don't think that's unreachable. It doesn't look unreachable to me. Okay, so we check for auto start. If the auto start delay has elapsed, then we play. If we play, then we'll on beat. I'm just gonna rename these functions on beat to on pre-roll beat, just so that we remember what we're doing. Okay. On pre-roll, per roll, on pre-roll. Pre-roll, did I do that right? On capital O, on pre-roll bit. Okay. Play state equals play state dot pre-roll. Okay, now we need to work out our song play start time. Okay. And song play start time, like we discussed, song play start time equals beat duration.
Sorry, I don't know how to help with that.
Jesus, sorry. Excuse me. Okay, song play start time equals beat duration multiplied by pre-roll beat count. Pre-roll beat count minus, and we subtract from that, we subtract our audio objects delay. So minus audio object dot start delay. Okay, so that's when the song should start playing. Okay. Okay, on pre-roll beats. Okay. So now, let's see. Whether we're playing or we're in pre-roll, we want to check for a beat. And on play. Okay, so now there's a few things that have changed here. So now we want to say beat count is 0 first. We want to calculate our beat duration. We don't really care about the start time anymore, or start time of when we hit that first beat. Don't care about that. Okay, so check for song. Okay. gonna pop this on. I'll log out. I'll log out just pre-roll started. Pre-roll started. BPM, beat duration, and also I'd love to log out the song play start time, because that's not sure how that's gonna work. Song start time plus song play start time. Okay, now we've got that. That's sort of making sense. I just want to check this on pre-roll beat. Last beat equals da-da-da. Okay, delta time equals time minus last beat. I'll check for beat. Yeah, that's right. Check for beat, check for beat. And when we play, last beat equals okay, this on beat, this last beat is now wrong. On pre-roll beat, last beat is just time now, I think. Okay, which means, yeah, so just... No, okay, no, that does make sense. So last beat equals... Okay, so we need a pre-roll start time as well. Just to calculate out. Oh, we do have a pre-roll start time. Okay. Last beat time. Okay, cool. Okay, play. Okay, I haven't set it yet. Pre-roll start time equals time.time. And so what we're able to do is from that we're able to use this. Instead of song play start time plus this, we say pre-roll start time. Plus beat duration times beat count. Okay, so let's step through this and see how that sort of would look. Last beat time. So, first of all, on the pre-rolls, let's say we have an audio delay. We have a delay in the song, delay in this whole thing starting of like 0.5 seconds. So then that would be a pre-roll start time. It would be about 0.5 seconds. Plus beat duration, which would be, in the case of 120 BPM, about another 0.5 seconds. And then multiply that by the beat count. Which gets incremental. At the first, beat count will be 0 because we're setting that into play. Beat count is 0. Beat duration we work out. Pre-roll start time is current time. That's looking good. Okay. So that's making sense for the first beat. Okay. Now let's work out the next step. The next step being, once we're in pre-roll, because we've set pre-roll when we've played. Once we're in pre-roll, let's check whether or not we should play the song. Okay, so delta time is pre-roll start time, time.time minus pre-roll start time. Now, if that delta time is greater than song play start time, then we should play the song. Okay. Song play start time equals pre-roll start time. Oh, wait. We've already worked that out. So we don't need that. And what's this one? Last beat equals time.time. We don't need that either. Literally all this is doing is it's just playing the song. On song played on Invoke. Invoke, okay. That's sort of making sense. So the delta time is, so if we've reached that song play start time, then just play the song. And we also need to recognize that we've grown into play state.songplay, which means that we're no longer going to check whether or not we should play the song. That's really essentially all that means. Otherwise, we still do the checking for beat, checking for a beat, even in the pre-roll. Before the song starts, we're still going to get 8 beats out of this. Or we'll get 7 beats and then one beat on the 8th. I think so. Yeah. Anyway, let's give this a go. Let's just see where it's at. It's probably a few little mistakes in there, which we'll find. Play state. So it looks like it's a little bit confused. Sometimes the solution, if you like move stuff around, it can because there isn't another unless play state is it? No, it's not a taken name. Okay. I'm gonna try out one little trick. If that doesn't work, we'll try out another one. Because I don't think this is a real error. I think it's a problem with the solution. Problem with how not a problem with the code, but a problem with how it's being read, or how it what if that makes sense. what the compiler thinks is there is not what's actually there. That's what I think's happening. Let's see. So let's go into desktop. Oh no, it's in Rhythm Blade. Okay, Rhythm Blade solution. Let's go ahead and open it. Sometimes Visual Studio is a bit better at opening, a bit better at resolving this sort of stuff than Visual Studio Code. Assets, scripts. Yeah, so for example, Visual Studio, my understanding is Visual Studio is now not complaining, whereas Visual Studio Code and Unity was before. So hopefully if we jump back in here, nope. Maybe it's worked. No, it hasn't. What if I save it again? Recompile. I wonder if play state is a taken variable. I wonder if that just already exists. But we were using it before, I think. Weren't we? Maybe we weren't. Let's find out. Let's just call it song play state. Public, and we'll say play state. We'll find all instances where the case matches and replace it with song play state. Whoops. Only do it once. Okay. I think we're there. Okay, almost. Does that make sense? Unity, does that make sense? No, it doesn't. No. Okay, so it's just chucking a hissy fit now. What I'm going to do is I'm going to have a go at just closing it all down and opening it back up again. I think that might work. Give it a go. Oh! No, it does. No, it's right. Because I've got this other one here. Whoops. Yep, you were right. You were right, Unity. I was wrong. My bad. Sorry for everything I said. God. So the case. Like, you know, when I'm programming, I'm like, oh no, the computer is certainly wrong. I know that I'm doing it right. And it's always ends up being something I've done that's really silly. Okay. Come on. I thought I fixed it. Okay. So what I'm going to do, because I've done this silly thing of copying and pasting a class. I should never have done that. I'm just going to comment out this entire class audio player. And then we'll need to just redo this one. Redo this object. Okay, now I think that is something I do need to update. Stop, pre-roll, and play. Okay, so instead of... Yeah, I prefer song play because song play is more explicit. You know, so there's it's not playing at all, and then it's on pre-roll, and then the song's playing. That makes more sense. Okay, let's close this up. Okay, now let's go into audio pre-roll. Audio player pre-roll. I'm going to pass in the funk the floor. Okay, on song play, we'll make sure that we play our audio source. Audio source play, and then on pre-roll beat, then we're going to get our target generator to recognize that. Target generator.beat handler. Okay, let's see how this goes. So there should be a real delay here. Should be 7 of these before we hear the music. And it didn't work. That's alright. Okay, on play. So this is what's triggering. I'm just gonna make sure this is where this is triggering. Log song started playing, so that we know that this is where that's triggering. I'll give that another go. Oh, I know. Yeah, no, that's right. No, that's right. Yeah, no, I was expecting 8 bars, like 8 whole beats, but then I'd have to put in 4 times 8. Because it's every beat, it's every quarter beat, if that makes sense. That's good. Pre-roll started. Song start time is 3.49. Yeah. Okay, so I just want to pause something. Just be really clear about what's happened here. It's really good. We could almost calculate exactly when that song start time should be, because we know that the auto start delay, nothing will start for half a second. So the whole thing will start at half a second. We know that each beat is 0.46. Let's calculate this. This will be worth calculating. So each beat is 0.46. So we should hear our first beat at 0.46 times 8. 46 times 8. Okay. That'll be when we hear our first beat. We've got to subtract from that our pre-roll start time, which is 0.2. 0.2. Okay, 3.48. This is again 3.49, which is close enough. I'm just thinking, is that right? Because the whole thing should start, like, you know what I mean? There should be a delay there. Let's try something else. I'm just trying to see if I set this auto start delay to 0. Will that give us the same answer? It does. Okay, so it's not taking into account our auto start delay. This is interesting. Okay. Why is that? Let's see, we're going to update. Okay, we switch play state. If it's in stop, which it starts off in, check the auto start delay, and then we play. And then how are we calculating our song start time? Okay, yeah. Okay, so our song play start time, this needs to add in, plus, it's got to be offset by when our pre-roll started. Pre-roll start time plus. Okay. That'll be better. So now it'll give us that same amount, just about 3.5. There we go. Yeah, see how it's spot on now? So we can even get a bit of rhythm here, right? We go like 1, 2, 3, 4, 5, 6, 7, 8. boom, 2, 3, 4, 5, 6. So we're getting those 8 beats before it starts. But did you notice that when it started, that cube was like still for a second? This is the interesting thing about this is why we have this auto start delay, is we need Unity to sort of load up the scene before we start saying, I want you to do stuff on exact intervals. Like, you see that little pause there? I think that's what's going on. That's why we put in 0.5, which will help us out, because at the moment we're getting start time at 3.51. Now it should be 4.01, about 4.01. Oh, so I don't know if you could see that. Okay. Yeah, 4.00. Yeah, that's much better. Except now it's not. Now it's not going to the beat. Why is that? Okay. I think the beat. Let's see, the first beat. Where am I saying first beat? I need to be clear. Last beat time equals pre-roll start time plus beat duration times beat count. Okay, I think I've looked over something here. Last beat time equals pre-roll. Okay, so when we play, we get that pre-roll start time. On pre-roll beat, I'm just gonna comment out some stuff that we don't need. Beat duration. Calculated the beat duration. Calculated the beat count. Song play start time. Yep. Song play start time, that looks good. And then beat duration times pre-roll beat count. And then we subtract the start delay. That looks good. On pre-roll beat. Okay, last beat time equals pre-roll start time plus beat duration times beat count, which would be 0. So yeah, the last beat time would be like, because this is a on pre-roll beat, this would be at the initial time. And then, oh, it looks right. It's supposed to be right. Let's just double check this. That was weird. See, there's like a little delay there in the log messages. 2, 3, 4, 5, 6, 7, 8. Two, three, four, 5. Okay, seems like the song's not starting at the right time. 1. Yeah, the song's too delayed. I'm gonna change up these values, see what happens. Change the auto start delay to 2. So we're 2 seconds before anything starts. Okay. I think I know. I might have a finger on what's going on here. That auto start delay seems to be taken into account with this one. I think I'm calculating the song play start time wrong. Okay. So let's see. So let's say beat duration is 0.5. Let's say it's 0.5. Okay, so this is an offset. It's got to be an offset from whenever the song started. So from whenever we started the pre-roll. See, what I don't get is just looks right. You say take the pre-roll start time. I'm gonna diagram it out. See if that makes more sense. Because there's a few things going on. It's no wonder it takes a little bit of massaging of the code to sort of get it there. Let's say we have a we have a delay of 1 second. So the pre-roll starts here. Right, pre-roll starts there. And then let's say we have a beat every 1.5 seconds, which would be beat duration times what do we say? What was it? The beat oh, what was the variable I called it? It was the pre-roll beat count. Okay, so let's say we want to calculate, like we want it to go for let's say 2 beats before we actually show the song. We want to pre-roll 2 beats. Okay, so that's 2 beats. So you go pre-roll beat 0, 1, 2. So beat duration BD equals 1.5. Pre-roll beat count PBC equals, I don't know, let's say 2. Then this looks right because you say you take the auto start delay AD equals 1. Well, that would be here, right? That's this distance, right? And then the beat duration times the pre-roll beat count is this distance. So add them together and you get the song start position, and then subtract the song start delay. It looks right. I'm a little bit confused here. Let's have another look. Let's get to the bottom of this. Okay. So pre-roll beat count is 8. Auto start delay is 2. That looks right. Go into our object, funk the floor. Start delay is 0.2. BPM is 130. That looks right. Okay, in our code, let's see. Audio player pre-roll. Okay, so if we're in a state of stop, let's check for the auto start. So it'll auto start 0.5 seconds after the game starts. If that's the case, then we say the song should play. Oh, there it is. There it is. I shouldn't be using a delta time for checking if the song plays. That's the one. Okay, that's the mistake. Okay, so now this should be the case. It should be if time, because the song play is not a relative to the pre-roll, it's an absolute time. Right, because we've already done that. Okay, so we say if time is greater than the song play start time, that's when we play the song. Okay, let's give that a go. Okay, we wait 2 seconds. 1, 2. Okay. 2, 3, 4. Boom. There we go. Beautiful. Might just listen to the song for a bit after that one. It's sort of starting to get a bit out of sync. I'm not sure if that's because I'm using this sort of start delay that I sort of made up before. or if it's actually because it's not exactly 130 beats per minute. Let's find out. It's looking good. Just gonna tap tempo again. Yeah. So it looks like it really is 129. Just shows that that 1 BPM really makes a difference. For example, if we go back to the code, it's probably way off by now. Yeah. See that? It's like completely off by now. So what I'll do is I'll change that 130 to 129. And we'll see if that gets it in sync. There we go. It's already looking more consistent. Let's let that play for a little bit longer, make sure we got that right. Spot on. Awesome. Okay. 1 BPM does matter, apparently. Awesome. Okay, so now we're sort of there. We're sort of there. We know that we're creating the beats. Let's say we're creating the beats creating the beats 8 beats in the 8 beats before we hear the sound. And what we want is we haven't quite gotten to there yet, because what we want is we want the target generator not to, well, okay, we do want it to create the beats at that time, but we want the beats to travel to a certain position at exactly a certain time. Because at the moment they're just being generated at that time, they're traveling at some arbitrary speed. So how are we going to do that? Let's give this one a bit of thought. Let's have a look. Okay, let's see. So I'm just going to open up the, where are we? Open up the, this one. Okay, let's imagine what's going on. Okay, so what do we know? We know that our target generator let's say our target generator is like 6 meters in front of the player. This is the player here. Ooh, okay, interesting. Okay, because this is let's say the player is here. This is your player, and this is, let's say this is the plane. This is the what do we call it? The hit plane or something. Hit plane or you know what I mean? Like the area where they're supposed to hit it exactly at that time. It's a little bit in front of the player. We don't want it to be exactly where the player is, or they'll sort of be doing these ones. Like maybe like, yeah, half a meter or a meter in front of the player. So we'll call this the hit plane. And we want this target, a target is being, I can tell you when I want this target to hit this plane, because I know that the target is being generated 8 beats in the future, and we know the beat duration. So there'll be a time. We'll call it target has like a hit time, hit plane time, or what is it? Travel time. Okay, well, yeah, this will be it. This will be a source pause, and destination pause. Okay, so and this is a travel time. Okay, and we can work this out. We can work out what the travel time is, because we know that in what is it, the pre-roll beat count, PBC, times beat duration, BD. In pre-roll beat count times beat duration, that's going to equal our travel time. Okay, so So we know that, think about it this way. Remember how we're working out when the song should start? Let's see, song should start at pre-roll start time, which is whenever our first beat's created, plus beat duration times pre-roll beat count. Now we ignore that because that's just got to do with the audio file itself. Okay, so it's the same thing as saying, this travel time is the same thing as saying, if we just think about our first beat, same thing as saying, when we hear the first beat, we want the first marker to hit this plane, okay? So, let's see, you know what I'm thinking? Because this is really common. We're calculating this pre-roll beat count times beat duration. We're calculating that everywhere. If you have a look at our audio player pre-roll, if I just go beat duration times pre-roll beat count, where else is that? Beat duration times. Oh no, that is different. Never mind. What I'm wondering about is how are we going to get this information? How are we going to get this information to our target generator? How are we going to get that information to the target generator? Well, we got a few options. We could say, let's see, on the song start, send that information from the audio player to the target generator. We could do that. But you see, this calculation is in fact, what we could do is, let's think about this pre-roll. Where do we want to set the pre-roll? Does a pre-roll belong to each individual song, or does it involve or does the audio player itself want to have like the same pre-roll for each song? Somehow I feel like depending on the song, you might want a longer or shorter pre-roll. That's like a difficulty, I think. I think it's like a difficulty. Because if you have really long pre-roll, you'll have the objects moving really slowly, because it's got a massive travel time. Objects moving really slowly, and you'll be able to see the majors away. So it is like a difficulty. In that case, because it's like a difficulty, and the difficulty, I'm just doing blatant Beat Saber cloning here. I'm just trying to think how it works in Beat Saber. In Beat Saber, you create a track that has a difficulty, and the player the song creator, the track creator tends to be the one who controls that. For now, this is what I'm gonna do. I'm gonna say per song you choose a pre-roll count, pre-roll beat count. Okay. Okay, so I'm gonna take that. In the audio objects, we're gonna be able to work this out. This will be let's see, we'll have a public int rather, pre-roll beat count. Let's say equals 8, and we'll have a public Okay, this will be interesting because that calculation can be done in here, right? And it's dependent on the beat duration. This is the other thing I wanted to do. I want to take this beat duration, and that really belongs to the audio objects. Okay, so we say this is a float, and what we're going to use here. I mean, if you haven't seen this before, this is called a property. And what it means is essentially saying, let's see, it's saying, this. I mean, it is technically you treat it just like you treat any other variable, but it works itself out whenever you ask for it. If that makes sense. So whenever you request the beat duration, it'll return 1 over BPM times 60. I think that's I mean, yeah, I'm not going to go into performance and the fact that you got to do that every time you ask for it. That's just not the scope of this. So, like, at this point in prototyping, that sort of thing, it's better to ignore performance because you'll get in the way of your own creativity and ease of what you're working with. Okay, so I'm hoping this is making sense. Just make this a bit easier to read. Let's see if that's how you... trying to remember how that looks. Okay. Now, we're also going to have another variable. That's right. Oh, right. I think I've got to enclose get. I forget the syntax. Okay. There we go. Okay. So we can work out the beat duration from BPM. Like maybe we could cache it, but let's leave it for now. Let's see. Look, I'll even write to optimize later. There we go. So we feel better about knowing that it's a little bit of a performance thing. Anyway, we've worked out the beat duration. The next thing we want to work out is I'm going to call it a beat delay. As in the time between when it pre-rolls and when you'll hear it. So this will be public float of beat delay. This is going to be really kind of similar to beat duration. Beat delay. Now that's going to equal. Let's see. That's going to equal return beat duration times pre-roll beat count. Okay. Okay, now I'm just going to double check I haven't broken anything. Plus audio object, beat delay. What else? What else was there? Beat duration. Oh yeah, beat duration is no longer here, and pre-roll beat count is no longer here. Where else do we ask? Okay, audio objects. Dot beat duration. Audio object dot beat duration. Okay, I'm just gonna double check I haven't broken anything. Oh, and I'll need to set it. I think I need to go back into the audio objects and make sure that I set a few things. Pre-roll beacon. Oh yeah, it's by default. Yeah, that works. Okay, hopefully that's just gonna work. Okay. Cool. Okay, now when we create our targets, we're going to need to say each target as it's created has a, it's going to have like a speed, which we're already sort of working on. This is a weird thing. Well, it's not that weird. It's not that weird. I'll retract my statement. Let's say we got our target generator. Now this is going to have a target prefab. We should call that target prefab. Target prefab. Now another thing that's going to have is what we discussed is the what do you call it? The destination. I don't know what you call it. Like destination plane. If you imagine you're a player, right? You have the target generators here, and there's like a plane that's like in front of you, like here. And you want to set where that is. So we'll call that a destination plane. Sugar. Whoops. Shouldn't have done that. Okay. Now, we need a direction. Instead of saying just to keep things sensible, let's see. Let's have a look at our target mover. This is what the next step is. So we've got our target generator and our target mover. We'll just say var target go equals. Okay. And what we're going to need to do is get the target mover, and instead of using this speed, we're going to set that by the target generator. The target generator is going to need to know about the audio objects as well. This is one way of doing it. We could use events to set some values, but I don't know. I kind of like this way of doing it. And in fact, I'm changing my mind. Because I don't like that if we wanted to change the song, we're gonna have to change it on all these individual pieces. So what I'm gonna do is we'll have an event on our audio player pre-roll. In fact, I'm going to delete the audio player. I'm sort of sold that I believe that our audio player pre-roll is the way to go, and it's working quite well. We're gonna create a new event, and that's what's gonna set our audio player. Set our audio objects rather. So this will be a serializable. In fact, it'll be really similar to this. This will be an audio objects event. Event, and what this is going to do is a Unity event of type audio object. What this is going to do is it's going to allow us to say in the audio player pre-roll, we're going to have event on pre-roll start, I guess, public audio object event on pre-roll start. And that'll allow us to pass in this audio object to our target generator without coding, which will make things nice and easy. Okay, so on pre-roll start, Play. Okay. On pre-roll start. On pre-roll start dot invoke. Invoke and pass in our audio object. Okay, and now a target generator just has a public void set audio object. And we'll set the audio object equals obj. Okay. Yeah, look, it's one way of doing it. I'm quite happy with it. It works. And now, our target is also going to need to know about, well, what's it really going to know? It's really going to need to know about its speed. And we can calculate the speed through this audio object. In fact, here I am I know I'm changing my mind again, but this is what it's all about. It's all about getting a really nice architecture that we can build off really easily. So what we're going to do is we're going to go ahead and... I'm changing my mind because I'm thinking the target generator doesn't need to know about all the BPM and the audio clip and all that sort of stuff. All it really cares about is this beat delay. That's all it cares about because that's how it's going to tell the targets how fast to move. So I'm just going to... That's a float. So instead of passing in an entire audio object, which is absurd, I'm just going to pass in the beat delay. Okay, so we just have to create a float event. Okay, and we're going to pass into there. Float, we'll call it beat delay. Okay, float beat delay. Okay, set beat delay. Okay. Okay, so what this is the amount of time between when an object's created and we want it to arrive at our destination plane. It's a time in seconds. And we'll need to convert that to meters per second. We'll work on that when we get there. Alright, so now let's go back into our audio player pre-roll. This isn't on pre-roll start. Instead, I'm just going to say, let's see. Oh, I don't know. Public float event set beat delay. Float event say why not? I'll just see how this goes. Set beat delay. Kind of interested. If this sort of ends up making sense. Invoke audio object dot beat delay. Set beat delay dot invoke. Let's see how it goes. Okay, so now we've got the amount of time that it'll take. Next thing we need to do in our target generator, we know that the targets will generate from the position of the target generator. We also want to tell it what direction for the targets to move in, and we also want to say how quickly they should move. Well, if we know the destination, let's work this out. Okay, so let's say set beat delay. So whenever we set the beat delay, let's work out how quickly our target should move. So we know the distance between our position and the destination plane. So we say, first of all, we'll get the direction. Vector 3, dir plane, dir dest plane equals destination plane. It's really we're only going to need this as a transform. Public transform destination plane dot position minus transform dot position. Okay. Now once we have that, we'll have float. We'll have the dest plane equals vector 3 dot distance. Oh, look, let's just go to the magnitude. Dest plane dot magnitude. Same thing. Okay, and now, got the distance to the destination plane. Now we need the direction. Sorry, this isn't the direction. This is a delta. This is a change in position. What we need to get the direction is another vector 3 third dest plane. It's just a delta dest plane dot normalized. In other words, it's whatever direction is, but it's got a magnitude of 1, which means that if we multiply the vector by any amount, then it'll give us some sort of direction and a speed. And so how we work out this beat delay? Let's see. So this is a distance from A to B, and we want it to take however long this delay is to get there, right? Okay, let's start really simple. I love just starting really simple. This is how we're going to work it out. Let's say that we have a distance of 5 and we want it to take 5 seconds to get there. Okay, so you've got your destination and your source, and you want to take let's say a beat what do we call it? BD, beat duration equals 5. You want to take 5 seconds to get there. Well, speed is meters over a distance over time, right? So speed equals d over dist over time. Our units are meters over seconds. Now we know how many meters we want to get. We want to get 5 meters. 5 meters over 5 seconds, which equals 1 meter per second. But then we could change that. So let's say, for example, you want it to take longer. Maybe you want it to take 10 seconds to get there. Okay, so beat duration equals 10 seconds. Well, then we say we want you to go 5 meters over 10 seconds. Well, what's 5 out of 10 is 0.5. So then you're going 0.5 meters per second. Now, if you multiply that 0.5 meters per second by a unit vector, right? So times direction dest plane. That'll give us a velocity that we should be traveling at, right? That's your speed, that's your direction, and then that'll tell us how our target should be moving. Okay, so let's go ahead and implement that one. Let's have a look. So this really should be I'm going to change the target move. It should be a public vector 3. It should be a velocity. And so really we just need to translate our velocity by time by delta time. Okay. So when we create our targets, we're going to need to set the velocity. And how do we work out a velocity? We know what the distance is. So I'll just type this in here. We go speed equals dist over time. Okay, so we can say float velocity, or let's call it speed. Speed equals distance to the destination divided by the delay. We don't need this one either. We don't need those two. I'm gonna change this variables to time. Time to destination. Anyway, yeah, that'll do. And it'll say vector 3. Oh yeah, now we're gonna keep our. This is what we need. We need a vector 3 target velocity. Okay, now we can just say target velocity equals speed times direction to the destination plane. Okay, which will give, yeah, that'll give us a direction and a speed. Now, I'm gonna, yeah, I don't really like this variable, this function name. I don't know what to call it yet. We'll just call it set velocity from time. That'll do. Okay, and now whenever we create our target, we just go ahead and say target go dot get component in children, just in case we end up putting it in a child object. Get component in children, target mover dot velocity equals target velocity. Alrighty. Yeah, I might break that out into just gonna break that out into an extra line there. Tm dot velocity equals target velocity. Alrighty. So now we're sort of starting to get there. I think this is ready to test. Let's see how it goes. So now in our audio player, we need to set, I don't really like that name. I'm going to call it, instead of set beat delay, that doesn't really make sense to me. Instead I'm going to say on pre-roll beat delay. Okay, so it's sort of describing it's describing what the event is on the pre-roll, and it's describing the event parameter that we're passing, which is the beat delay. I think that sort of makes a bit more sense. We'll see how it looks, and maybe change it a bit later. We'll see how we go. Okay, so when we do that, we're going to pass in our target generator. To do set velocity from time. Okay, and now our target generator is also going to need our it's going to need the target prefab, and it's also going to need the destination object. For now, I'll literally use maybe I'll use a quad as our destination. Okay, that's cool. So we've got our target generator, and our quad might as well be a child of the target generator. Wait, no, it shouldn't be. Change my mind. It shouldn't be. Okay. Now, now I'm just going to set quad. Okay. Okay. Just going to make sure these log messages aren't coming out every beat. Let's see how that went. Let me change my auto start delay to 1 second instead of 2 seconds. So it goes. That's looking really slow, isn't it? Okay. So this isn't quite right. What I'm going to do is I'm going to log out the target generator. Let's log out this time. Okay, so let's debug.log time plus speed. Okay. Just see what sort of values we're working with here. It looks a little bit slow. Okay. So This is saying I want it to take 3.7 seconds to get to the destination, which is taking longer than that. And we want it to travel at 0.2 meters per second. Okay, first of all, let's calculate that. Okay, so we know that we'll use our heads to calculate this. We know our quad's at 0 and our target generator's at 10. We know that the distance is 10. We know we want it to take 3.7 seconds to get there. Well, 10 out of 3.7, what's that? 10 divided by 3.7, 3, should be about 2 point something. 10 out of 3.7, I think? Yeah, 2.7, okay. And what are we getting? Speed 0.26, oh. Maybe it's, yeah, because it looks like the speed just needs to be multiplied by 10 or something. It's weird. Distance over time. Time is in seconds, distance is in meters. Doesn't make sense. If time is 3.7 and distance is Oh, I know. Delta. Okay. I was saying, what's the distance of a unit vector, which is the direction, which is always going to be 1. But really it's 10. Okay, that's much better. Okay. Cool. Okay, this will work. I'm just going to turn off log messages. Okay, there we go. So, nice. See that? It's like hitting this plane right. Excuse me. It's hitting that plane spot on. Okay. Quite happy with how that's working. Alright guys, I'm going to take a quick break. Leave it at that for now. And I'll come back and we'll do collision and then points. So that we're actually able to hit them as they come out. Maybe we'll have them change up where they're at, what position they're at as well. Okay, so let's put on a little timer. Minutes. 5 minutes. Oh, look. Make it 7 minutes. Alright. I'll be back. Alrighty. So, where are we at? We got we're sort of getting through everything. We've got two more things we really want to do. We really want to have it collide with something. Have like I'm gonna call it like a target smasher, a target collider. Yeah, just call it a target collider. We want a target collider. No, that's confusing. It's like, is that a collider on a target or on the thing that's hitting it? I prefer target smasher. We'll use a Beat Saber mentality. Okay, so we've got a target smasher. Target smasher, and then we want to somehow display to the user that they've smashed the target, have the target be destroyed, and increment some sort of score. Okay, so let's start off with a target smasher. Target smasher. Okay, I'll just give it a sphere as a child. For now, maybe make it, I don't know, like a football, like a foot long or something, 0.3, something like that. Okay, so it's got this sphere collider. Now we don't want it to do any, like, well, maybe we do later. Maybe we do. Maybe we want it to, like, like actually smash the target like a baseball or something. That'd be sick. Yeah, okay, here we go. Let's try that. I was about to say we don't want it to do physics, but why don't we want it to do physics? Okay, so we're going to need a sphere collider and a rigid body, which is, let's see, kinematic. I think it's kinematic because we don't want it to move. Wait a minute. We want the targets to fly off, not the collider. Sorry, I'm just gonna quickly. I always forget. Like, what is this? Is kinematic? Is kinematic? What does that mean? Forces, collisions will not affect the rigid body. Yep. Yeah, that's good. Kinematic bodies also affect the motion of other rigid bodies through collision. E.g., can connect a kinematic rigid body to a normal rigid body with a joint, and the rigid body will be constrained with the movement of the motion of the kinematic body. Yeah. Okay, this is good. So what this is saying that let's say, for example, we have a rigid body attached to our hand, and wherever it goes, it'll hit the targets, and then the targets will fly off, but the rigid body on the hand won't fly off. Okay, so we want a kinematic rigid body, and we'll leave everything else as default. We won't use gravity, and then in our target, we'll just give that a rigid body as well. So the target will be affected by gravity. Yeah. Okay. No, I think this is doable. We're going to need to change the target's velocity to being set by setting by the rigid body. We'll get there. All right. Step by step, we'll get there. This is going to be cool. I think it'll be a lot of fun. Okay. So where's our target prefab? First of all, I'm going to make sure the target has. Let's see. Open the prefab. Make sure the target's this cube. I'm going to give the target itself a rigid body, and the cube will be the collider will be a child of the rigid body. Oh, does that work? Maybe they need to be on the same object. Yeah. Okay, so what I'm gonna do is I'm gonna copy this component, or this box collider component. We're gonna remove it, and I'm gonna paste the box collider on the same component, same game object as the rigid body. Okay. Oh, which means it doesn't scale. What I would love to do is this. Okay, so we want the mesh to be separate from the collider. They're just two separate things. One is how something looks, and another is like where it gets hit. I'd love for it to be this. I'd love for it to look like this. This is my dream. Okay, target has a mesh, and it also has a collider. Now the collider is a child of the target, which has a rigid body. Okay. Okay, yeah, I'm hoping this will work. 0.2 or 0.3. That'll do for now. Okay, so it's got a rigid body. There's no box collider on the rigid body. Okay, is this making sense? I'm hoping this is making sense. So what this means is, what this means is that we have this. Sorry, I'm just setting up the chat. What this means is that we have our target, which is really simple. It's just got a script on it and a rigid body on it. And then as a child of that, we have a mesh and we also have a collider. Now I think that'll work. I'm just going to quickly test that. Let's see, just create a new scene. Whoops. Save. Okay, we're just going to quickly test the target. Let's see if we have our target, and let's say it's at some position. I'm just gonna disable. We're gonna need to redo the target's velocity anyway, because it's gonna need to be like, is it in coming towards mode or in physics mode, that sort of thing. Okay, now let's go ahead and create a plane below the target. Okay, now because at the moment, right, at the moment we've got this target, and it's got a rigid body and a collider as a child. Now if I disable the collider and enable gravity, it should just fall straight through the plane, right? Yeah. Okay, cool. Okay, so it just falls through the plane unless, let's see, if I enable the collider as a child, does that affect, this is the question, does it affect the rigid body? It does, beautiful. Okay, so a collider can be a child of a rigid body. That's what we've discovered. This is really good because it makes things much easier to sort of to work with. So you have your mesh separate from your collider. It means they can have different scales and really, like all that stuff much easier. Okay, so that's that. Let's go ahead and apply that to the prefab. I'll just save this scene as target test. I'm going to call it, oh wait, what am I doing? Save this, what am I doing? Save the scene as target test. And this is also the scene we'll use to test our what is it? Our target smasher. I think I started making the target smasher over here. Yeah, target smasher. Oh no, I didn't really. Okay. I just gotta, while I remember this, rename this to a target destination. Does not need a collider. Okay, that'll do. Back into our target test, I'm going to go ahead and create a new object, call it target smasher. Target smasher, and this will simply have a sphere collider attached to it. So just call it collider. Go ahead and give it a sphere collider component with a radius of 0.3. No, that's massive. That's more like a radius 0.15, so about a foot in diameter. Okay, now target smasher, child of target smasher, and then we'll have a rigid body which is kinematic, which means that it will still affect the targets, but it won't get knocked around by them. Okay, so let's do an example of that, just so that we're absolutely sure of how it's working. Okay, so we've got our target. We've got our target smasher. Just going to move the target up a little bit. Target smasher, which doesn't have a mesh yet. So let's go ahead and add a mesh to it as well, so we know what we're looking at. Mesh. Give it a mesh filter. Mesh renderer. Give the mesh renderer a material. Default diffuse will do. And for the mesh filter, which is a sphere as well. That's a bit big, isn't it? So the mesh will have a scale of 0.3 for now. Okay, there we go. So we've got, okay, cool. So we've got the mesh renderer and the glider are the same size. Now, we have a target that's above the mesh, a target that's above our target smasher. So in theory, because we're using gravity on a target, the target will fall on the smasher and then just like drop off to the side. Oh, maybe because it landed exactly on the top, it didn't do that. Let's give this another go. What if we move our target smasher slightly to the, I don't know, slightly forward? Okay. It's like you're balancing on a sphere. There we go. Okay. Now, for example, if the target smasher was not kinematic, then I think the target smasher will get knocked around by it. There you go. Okay, cool. Which we don't want, because it'll be like attached to a controller. It'll be, the target smasher will be attached to a controller. Okay. So, let's go ahead and save that as a prefab. Save the target smasher, let's see, prefabs. Target smasher. Make sure, the target should not have gravity. Oh yeah, and this is where we've got to test our target. Okay, so I'm going to have the target to be at 0, and on the z-axis it'll be at 10, right? I'm just going to manually set the target's velocity to -1 on the z-axis, coming towards our player object. Now what we want to do is we want to say, if the target is in free mode, like flying towards a player, then we do want to apply this velocity to it. But as soon as it gets hit by the player, just go into physics mode, essentially. With gravity would be cool. With gravity would be awesome. Yeah, okay, so let's go ahead and open up our target mover script. Okay, and so we'll just go rigid body RB equals get component in parent rigid body. Okay, now we're going to need to say we're going to need one more script, and that's the target collider script. Target collider, because our target collision, we're going to need this on collision enter function, which will only happen on the game object that the collider's on, I believe. I might be wrong. Let's find out if I'm wrong. I might be wrong. Let's see. On collision enter. Debug.log collision. Okay. And on update, on update. No. We just want to apply the force once. Public void apply force. Apply velocity rather. Okay, vector 3 velocity. Okay, just gonna do this for now, just because I'm thinking about how this is gonna work out later on as well. You know how the target generator is going to apply the velocity maybe just once, so we don't need to cache it like this. We can avoid this sort of stuff. These global variables can just get you into trouble, so we'll try to avoid that. Okay, so apply velocity rb dot add force velocity, Now force mode is where we get interesting because we've got a few. Okay, at a continuous acceleration to the rigid body, ignoring the mass. A continuous force to the rigid body using a mass. Instant impulse to the rigid body using its mass. Instant velocity ignoring the mass. Okay, so I believe what this means is a force is like, what is it, newtons per second? So for example, I would use force if this was happening every update frame. It would take into account that delta time. I think that's what that means. Whereas we just want a velocity change. We don't care how much a thing weighs. We know how fast we want it to move. So that's what we're going to use. Okay, now we're going to say RB dot add force. Oh, sorry, apply velocity. 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 Okay, that's just to start off with. Now, hopefully... Oh, right. Sorry, that's not RB. It's just apply velocity. Okay, so now hopefully we're going to get a collision, even though this rigid body, this game object's a parent of the collider. Let's find out if we do. Okay, so ideally our target's going to start moving towards our smasher at 1 meter per second. So it should take about 10 seconds to get there. 2, 4, 5, 6. Yeah, that's looking right. 9, 10. Hey, and we do get a collision event on the parent object. So what I mean is our target mover script, which is listening for a collision event, heard a collision event on the even though it happened on the child object, which is really good. Okay, now we want to say target smasher. We want to give that a tag because what we're going to say is we're going to say if the target smasher's collider, if the target smasher's collider has a tag called target smasher collider, then do a thing. In other words, only listen for a collision with this particular, an object with this particular tag. Okay, so in our target smasher collider, set the tag to target smasher collider. And then in our target mover, we say if collision dot transform dot tag is equal to target smasher collider. Then log collision. Okay, is that right? An object reference. Oh, if collision, right? If other, sorry, if this shouldn't be called other, it should be called collision. Okay, so now I should only register with this particular one. I just want to test it out. I want to speed it up a bit as well. So let's go ahead and change the speed to, I don't know, 3 meters per second. 2, 3. Okay, now that didn't work. Why didn't it work? Target smasher collider. So what I'm going to do is I'm going to print. I'm going to log the other collision.transform.tag. Log collision.transform.tag. See what sort of value we're getting out there. Okay, I believe what happens is if our target smasher has a rigid body, then it's calling the target smasher's transform. Which is cool. I'm just going to change the tag in that case. I'm going to change the tag to from target smasher collider just to target smasher. Okay, just to be explicit, tag is target smasher, and then let's see if that's what's happening. Cool. Okay, so now it's equal to target smasher. Okay, so now we're gonna set, once that happens, because this is gonna be like a target mover. Once that happens, we want to, what do we want to do? I don't think we want to do anything other than turn on gravity. Let's just try this. We just say rb.gravity rb.setGravity, rb.useGravity equals true. Okay, so then it just drops out of the sky. And then I've got an idea for how we want it to bounce away. Perfect. Alright, what we need to do is we need to set the target smasher's material, its physic material, to a really bouncy material. Okay, so there might even be one by default. No, there's not. Okay. Assets, materials, or it's not really a material. I'll call it physics. Physic materials. Let's go ahead and create a physic material. Physics. I know we're sort of digressing. I wasn't really going to use physics, but it's a lot of fun. Okay, physic material. Here we go. Okay, we'll call it bouncy. Friction is 0. Static friction, I think they're kind of the same thing. I don't know. Bounciness is 1. Friction combine is maximum. Bounce combine is maximum. In other words, friction combine is minimum. In other words, when it's saying two physics materials collide with each other, which one does it listen to? It listens to this one. This one will override all other physics materials with no friction and maximum bounciness. Okay, I think that'll work. I believe that'll work. So now, if we go to our target smasher, set its physics material to bouncy, what we should see, hopefully, is the object bounce off at the same speed as it was going before. There we go. Beautiful. Now, if the target smasher was moving really quickly, hopefully we'll see it moving faster away. So let's say, for example, our target was moving at, say, 10 meters a second, massive 10 meters per second. It should really fly off. Boom. And now, if the target was slightly above, the sphere, like say 0.05 or 0.1, let's say, then hopefully we'll see it bounce up. In other words, a player would be able to hit the target in a certain way. Okay, that didn't work. I was hoping that it would set its trajectory at a normal to the collision. Why didn't that work? Oh, we'll look into that later. I'm getting too into it. I think I'm getting this is too specific. We got other stuff we need to look into. Okay, we'll leave that one for now. It's working for now. That's good enough for now. Okay. So now we know our target is going to disappear. Next thing we need to do is we just need to say the target needs to destroy itself after a certain amount of time. Let's say, I don't know, like 2 seconds. So we just have I don't know, lifespan. Let's have a lifespan. Public float, lifespan equals, let's say they only exist for 10 seconds, no matter what. Okay. So we say, we call it float birth year, birth time. Why not? Birth time. Okay, birth time equals whenever it was initialized. Okay, and now on update, if time.time minus lifespan is greater than minus birth time is greater than lifespan. Destroy game object. Okay, so it'll destroy itself if its lifespan's gone. That it'll destroy itself if it's been alive for longer than its lifespan. Now, next thing we want to create is a target smasher target smash listener that's going to exist on the target smasher itself. Okay, so we'll go ahead and create a target smash listener. Target smash listener. And this is going to be quite similar to our target mover. It's going to have this on collision enter. And it's simply going to have an event. Let's have an event. Just say, just for now, I'm just going to create a simple, just so I don't have to import Unity events all the time. I'm just going to create a simple null event or void event. Just so that we can just say target smash listener has a void event on target smash. Okay, on collision enter, if the other transforms tag is equal to target on target smash dot invoke. And we can hook that up to sounds. We can hook that up to a UI, all kinds of things. Okay. Next, I'm just going to create a scorekeeper. Yeah, why not? Create a scorekeeper. Okay, mono public void increment score by some integer. Okay, int score equals 0. All right. Score plus equals amount. Okay, now we'll have an integer public integer. I'm just thinking about how we're going to connect this to the UI. So the scorekeeper will increment the score, and also will have an event on score change. Public int event on score change. Okay. Now we just say score plus equals amount, and now on score change dot invoke with our score. All right. Now for our UI elements, they're going to have like a prefix, so it'll be like something that says like score and then the amount. So let's go ahead and create I don't know what you call it, a text setter, for lack of a better class name. CS. Okay, there's a mono. This will have a public string prefix equals, just say value by default. Public string suffix equals nothing by default. Okay, and this will be a public. You're also going to need a UI using Unity Engine.ui. This will also be a public text. Okay, now we say public void set text. Pass in an int value. Okay. Text.text equals prefix plus val dot to string plus suffix. Okay. Look, we can do this with a few different ones if we want. You know, we do it with a float, we do it with a string. Just by default, I'm just gonna make the float only go to let's see, what is it? N0? I think that's N2. I think that's how you do it. Make the float only go to 2 decimal places. Okay, so now we've got a text setter. Got a scorekeeper. Got a smash listener. Let's go ahead and test this out. Let's go ahead and I think we've got enough to build a score incrementer. Okay, so what's this? On target smash. Oh right, this needs to be public. Okay, so I'm gonna create let's see, on a target smasher, we'll have a target smash listener. Now on our target itself, we need to make sure it's got a tag called target. Okay, target, set tag to target. Okay, I believe I think that'll work. We'll see. Target mover is fine. Now, target smasher has a target smash listener. And we're going to attach that to a, let's just call it a scorekeeper. This really should be, it shouldn't be an object. I don't like to put objects in the scene that don't have a, they don't need a position. The scorekeeper really should be a scriptable object. Anyway, we'll leave it for now. Maybe we'll put it in later. Okay, on score change. Okay, so what we want to do is we want to say target smasher dot target smash listener on target smash. We want the scorekeeper to increment by increment score. Let's say increment score by 10. Let's just say that for now. Okay, and now we've got our scorekeeper. On score change, let's go ahead and create a UI. Create a UI text object, which will update whenever the score changes. Okay, so now I'm just going to add to this text object. I'm going to add that text setter. Pass the text object into it. Okay, and instead of value, I'll just call that score as a prefix. Now, on our scorekeeper's score change, all we need to do now is set our text setter's text to that new value. Okay. One thing I'm going to do is when the game starts, the scorekeeper really should call that. So public start, because otherwise the text editor won't have any value initially. So we want it to equal 0 at the beginning. Okay. Now, we just need to find it. I can't really see it on the screen. Let's see. I usually like to use. Oh yeah, that's right. X 0, Y 0. Oh, there we go. Beautiful. Okay. This one I usually like, top left. Yeah, I kind of like top left. Okay, pause X is 0, pause Y is 0. I think Y needs to be, see, a little bit down. Oh yeah, and I think the text, I like to put it justified to the center. So you're talking about the center of the box where you want that to be. Maybe just up there. I'm looking at this thing, by the way. Probably make this a bit bigger. Okay, looking at this text box. Okay, the canvas. It's an overlay, constant pixel size. I like a canvas to scale with the screen size with the default of 1920 by 1080. This is how I like to do things. Just so that if you end up using a mobile and stuff like that, it'll work. Oh yeah, and turn off on our text, just horizontal overflow, vertical overflow, so that if you make really big text size, you'll still be able to see it. The big font size. Okay. Beautiful. All right, so let's see if we miss anything. Score is 0, and then when a thing hits, score is 10. Beautiful. I think we're ready to test this. Let's say score 0 by default. Okay, I'm just going to save this as a prefab. Make sure I'm not sure if this does this automatically. I'm just going to go apply all to my target smasher. Yeah, okay, yeah, I do need to do that manually. I think that's why there was a bold before. Okay, target smasher and target have both been applied. And the canvas, I'm going to set as a prefab. I'm just going to call it overlay canvas. Overlay canvas, okay. So, Okay, this is why I really want to create that scriptable object for the scorekeeper. Okay, so you notice how hey Yazda, good to see you here. You notice how the scorekeeper is now referencing this text box, right? Now, what would happen if, because this scorekeeper is going to be its own prefab, we could make it its own prefab, and this text is its own prefab, they don't know about each other because they're talking about instances of each other, which makes it difficult. It means every time you bring them into the scene, you've got to hook them all up again, which I don't like. So what I'm going to do is do this. I'm gonna have the scorekeeper, instead of being a mono behavior, it shouldn't be a mono behavior, because mono behavior literally means exists in the scene, has a transform, and this sort of thing, which it just doesn't need. So what we're gonna do is we're gonna change this mono behavior to scriptable objects. Scriptable objects. We're gonna create an asset menu. And we're going to be able to create an instance of a scorekeeper. And then all we need to do is, I believe, I might be wrong here, but I think awake is how we do that. I'm just going to log. I'm just going to check. Oh wait, I want to check something. On enable, because I like on enable. Object becomes enable and active. I wonder if scriptable objects actually become enabled and disabled when a game starts and finishes. I'm not sure. Let's find out. Enable log enabled. Okay, I'm just going to test this out. Okay. So, because why this matters is we want to reset the score every game. Okay, so I'm going to delete this scorekeeper, which will break everything we just did, but it'll fix it in the long run when we start moving it into other scenes. Okay, so now I'm going to create a scriptable object called scorekeeper, right? Okay, now I think I already did that. Okay, yeah. Okay, so it got enabled. If we hit play, cool, it does. That's really good. So, for example, what that means is because this integer is private, it's not serialized, which means it'll get set to 0 every time we start the game. Awesome. Which means we can do something like this. I think this will work. Okay, on score change. On score change. Now on score change we set the text, but problem now is that now we're setting the text of something that exists in the scene. I don't think it'll like that. Yeah, it doesn't like that. It says no, I'm a scriptable object which exists out of the scene. I don't want to talk to something that exists in the scene, which is cool. There's a way around this. We need to create something called a game event. This is I'm just gonna look. This is a digression, but it's worth getting into because this is like the really nice way of working when we get our head around it. If you have a bit of spare time, check out this video. It's kind of a little bit mind blowing. Just go to let's see, just type in scriptable object. Sort of I don't know, change a bit of the way of how I approach this. First video comes up. Unite Austin, game architecture scriptable object. Kind of change what I want to do when I'm creating my games in Unity. How I want to do it. Anyway, so yeah, really highly recommend this video. In it, the gentleman, what's his name? Shell Games. Yeah, but that's not it. Oh yeah, Robbie Ryan. There's his GitHub. Oh, I can't remember his name. I think he's got a website. Rubber Ryan. Oh yeah, Ryan Hipple. Okay, yeah. So Ryan Hipple talks about this problem about how you have a scriptable object that wants to make something happen in the scene, but the scriptable object can't know about a thing in the scene. What we can do is we can have what we'll call an event. Let's see if I can sort of work this out from what he was describing. Okay, so we're going to create our own event, right? Create our own event that's like this, and then our text is gonna subscribe and unsubscribe from it. Yeah. Okay. So I'm just gonna show you what this is gonna look like. This is interesting. You know, we're learning about how to make a VR rhythm game, but we're also learning a little bit about architecture, because that's how we make something that we're going to keep wanting to work on and add features to, and you know, it won't get confusing. All I need to do is just open up this. Here we go, the sync pane. Okay. So what we're going to do is we're going to have we got our scorekeeper, which is a scriptable object, right? We've got our scorekeeper. Now we're also going to have an event called score updated. Okay, which is also a scriptable object. Okay, these live in asset world. Okay, then in runtime, in the game, in the scene, we're going to have we'll call it I want to call it an asset event. Call it an asset event. Asset event. Now we'll have an asset event listener, right? Runtime will have because runtime has this text box. This text setter, right? And the text setter. Yeah. Okay, this text setter has a function which is like set text, and what we want to have a Unity event which is a response to this asset event. Okay, so this will be our asset event listener, which will have a Unity event. You know, which will mirror the asset event. And and the Unity event's going to set the text, and the asset event listener on enable is going to attach itself to the asset event, and on disable will detach itself from the asset event. Okay. Okay. So yeah. Okay. So let's go ahead and make that. Let's give it a go. Give it a go. See how it goes. Scripts, new folder, asset, events. Okay, now we'll create a asset event. .cs. Scriptable objects. Asset events. I'm going to call it asset event. Now each asset event will have a type. So this will be a void. Void new void asset event. Okay, and now this is going to have a public list. Oh, you're also going to need asset event listener. Asset. Okay, asset event listener. We're also going to need a container. I'm wondering, because the asset event listener needs to be, it can't be a mono behavior, I don't think. Or maybe it can be a mono behavior. Let's see. Mono. Asset event listener. I think it can be. Public. It just can't be serialized. Asset event listener, listeners. I really should call it a void asset event listener, I think. Yeah. Anyway, I think this is how it should work. Void asset event listener. Asset event listener. I think it should be like this. Asset event listener void. Asset event listener void. Okay, and now asset event listener void. Okay, because this is a void asset event. Oh, now this is going to use system.collections.generic. Okay, and now we'll have a public void add listener. Asset event listener void listener. We might need to change this in the future, but it's sort of getting the idea. If it's not true that listeners contains listener, then listeners dot add listener. All right. Now we also have remove list public void remove listener. Remove. Oh, it's so similar to this one. Just copy paste. Remove listener. If it's true that it contains it, then we'll remove it. Okay. And we'll also have another void, another public void invoke listeners for let's see, listeners. Can we see this? Dot for each l dot invoke. Okay, looks really basic. This is sort of what's going to enable us to this is what's going to enable us to have our assets and our runtime talking to each other. Okay. Now, our asset event listener is going to simply have, let's see, what's this complaining about? Oh, don't worry about that. Our asset event listener is going to have a Unity event, public void, we'll call it void event. Void event response dot invoke. Okay. That's essentially it. Oh yeah, and now on it, it's also going to have an asset public void asset event. Asset event void. I think I should call it a asset event void. Kind of prefer that. Have the type at the end. Asset event void. Asset event. Okay, now this is what's interesting. On enable, asset event dot add listener this. On disable, asset event dot remove listener this. All right, awesome. We should probably test it. Oh, I mean, I should really test it with an integer because this is a void asset event. We really need an integer one. Okay. Look, I'm just gonna quickly do it. I'm just gonna quickly copy paste. I know. I'm gonna redo it later. But for now, just to test it. Asset event integer. Okay, this will be an integer, asset event slash integer. Okay, and this asset event listener int. Okay, which doesn't exist yet, that's alright. And this is going to be integer val l.invoke with the val. Okay, now let's go ahead and create that asset event listener integer. I know. It's copying and pasting. It will be okay. It'll be alright. Asset event int. Okay. Too easy. I think that's on it. And I think we can ignore that asset event listener void. I think that'll be fine. Oh yeah, and asset event list int needs to invoke with some sort of val, some sort of value. Response will invoke with that value. Alrighty. I know I'm getting lots of red here, but it should be okay. I think it's okay. It doesn't already contain namespace for asset event listener void. It doesn't. Okay, let's see how that went. Oh, right. This should be int event. Int event for the int. We'll change all that later. We'll change it to generics and whatever. But for now, that'll be fine. Okay. So, what have we done? What does this really mean? What does it sort of boil down to? Well, if we have our scorekeeper, yep, that's good. It's got this event on score change. Well, now we can create a new asset event, which will be a integer asset event, score changed event. We could just call it on score change. On score changed. Okay, now that shouldn't, I don't think the listener should be public. Let's go change that. Asset events, public, that shouldn't be public. We shouldn't be able to see the listeners. I think, it shouldn't be public. Because it's meant to be automatic. I'm going to remove that enable and disable as well. How did I do that? Scorekeeper. Okay. So, let's see. Our scorekeeper is going to invoke on score changed. On score change, asset event dot invoke. Now, our text, we're going to create a integer asset event listener int, which will be on score change. On score change, and the response will be to set the text. Set the text to some value. Okay, and now the cool thing is, the really cool thing is that our target, all of our prefabs will work in their own separate world without needing to be connected together. So now our target smasher is able to say, set the target smasher, set our scorekeeper increment value, right? So scorekeeper dot increment value, increment score by 10. Okay. All right. This is kind of crazy. Let's see if it works. No, it didn't work. That's all right. Let's figure out where it went wrong. Okay. So let's go ahead and in our scorekeeper increment value, let's just go debug.log scorekeeper bang. Okay. On score change, which will send it to our asset event. We're calling asset event.invoke. So our asset event, let's see, invoke asset event bang. Asset event bang, and then for our asset event listener int, I'm going to say asset event listener int bang. Okay, let's see where the line of communication broke down. Okay, so the scorekeeper got it. Asset event int.invoke on score changed. Asset event int.invoke. Scorekeeper. Increment score. Scorekeeper bang on enable on score change.invoke. which is connected to our event. Now why isn't that calling? That really should have called. Asset event listener int.invoke, which is an asset event listener int.invoke _ change. Now that really should have that really should have called. I'm not sure why that didn't. Yeah, well, first of all, scorekeeper. Maybe I'm not supposed to use. Maybe I'm not supposed to use Unity events in scriptable objects. Maybe that's what's happening. Unity events in scriptable objects. You can get an okay, I'm going to try something else. I'm going to try another approach. Instead of the scorekeeper having a Unity event, which it really doesn't need, I'm instead going to just have an asset event. Asset event int. Okay, so now it's essentially the same thing. On change.invoke. It's kind of just, yeah, it's just kind of simplifying it a bit. That might work. That might work better. Let's find out. Okay, so now I'm just setting it directly to that _change. Hey, that worked. 40? How did it go from 0 to 40? So 0. So 50. Oh, is it not resetting? Score 60. Okay, it's not resetting. Okay, so int score is 0. We really want to say on enable score equals 0. I think. Score plus equals amount. Yeah, I think so. Let's just check the first round. Let's check the first round. Okay, scorekeeper bang, asset event bang. Okay. Well, we can already see a problem here, can't we? Because if I slow things down a little bit, our scorekeeper is calling, our asset event is calling, but because this is on enable, and our asset event is on enable, our asset event listener has not had time to attach before that function was called. So the scorekeeper really needs another event like on after enable. Something like that. Unless our asset event listener, instead of on enable, was awake, which I believe occurs before on enable. Is that right? Maybe it doesn't. Should find out. Okay, well, let's go ahead and play. No, it doesn't. Let's go ahead and wait. I just want to check this. Unity order of execution. Okay, awake. Oh yeah, awake does occur before on enable. And why didn't it work? Not fair. Not fair at all. Hold on. Asset event listener. Okay, on awake, asset event add listener. This, yeah, that makes sense. On disable, remove it. Asset event dot on enable. Scorekeeper dot on enable. Score equals 0 and log scorekeeper bang. Yeah, no, that should have worked. Asset event bang. It should be calling this asset event listener bang. Should be calling that one. But it's not. Because what that means is our text box, if this equals something random, NA, for example, then it doesn't get set till that first instance. Okay. Okay. Look, I'm gonna cheat here. This is something I was thinking about earlier, and I was thinking like, what would be the best way or a nice way to do something? Look, we shouldn't be calling on awake. We should be calling on enable. What we need. The problem with this is really funny. This is just the architecture which we're really happy to be working with because God knows we couldn't do it by ourselves. But the architecture of Unity will only give you a lifecycle hook for something that's a mono behavior that has a position in space, right? So what we need to do is we need to have a lifecycle hook, like a lifecycle, you know, or whatever we want to call it, game event. What is this called? Order of event functions. Lifecycle flowchart. Okay, you just call it a lifecycle events. I just call it, yeah, lifecycle manager. Manager, I don't know. Lifecycle, what do you call it? Razor. No, lifecycle event razor. Event razor? Yeah, I think that'll work. Okay, this is what I'm thinking. This is what's in my mind, right? What we need is a utility class. It's kind of like a utility class. It's just called a lifecycle caller. Well, yeah, lifecycle caller. Lifecycle events. I like lifecycle events. Okay. All this is going to do is have a list. Oh no, not even a list. It's going to have a void event on start, void event on update, and that's it for now. That'll do. Start on start dot invoke. I know this looks ridiculous. Update on update dot invoke. Okay, we are going to need this. We're going to need a lifecycle event, and look, this would be attached to like a game manager object or whatever. Just something that's able to say, okay, when you start, scorekeeper, do something. Once everything's hooked up, right? So instead of scorekeeper saying on enable, forget that. Forget all that. Scorekeeper can just be done as. Literally just does that. Okay? And now, what's this event system? No, that's different. That's different. Okay, we just call it lifecycle events. And we're going to attach our lifecycle events, cycle event scripts. I'm just going to make sure those are public events. Public void events. Okay, now on start, we're going to go ahead and have our scorekeeper. Oh yeah, so we just need to. Oh, you just say increment score by 0, why not? Oh no, look, that's not right. It's not right. I can't let myself do that. Public void initialize score. No. Better yet, let's skip that. Let's just skip the scorekeeper. Leave the scorekeeper as it is. This is the nice thing about it being so modular. All we need to do is call on score changed. Dot integer. Let's just invoke with 0. Okay, on score change 0. Now we go from score being NA. If we play this, there we go. Score is 0. Everyone's happy, and it goes up to 10. Beautiful. Although I believe I did remove something which I needed there. On enable. Score equals 0. I think I did need to keep that in because it seems like that score doesn't reset itself. Let's find out. Without that, score 10, 20. Yeah. Okay. So we do need to do that. So now I'll go up to 10. From 0 to 10. Beautiful. Okay. Lovely. just going to remove all these bangs I made. Asset event bang. And asset event list in bang. I'm really excited about this. I've never really tried this out before. I've sort of been like listening to it for a while, listening to people talk about it. I haven't really tried it. I'm kind of excited to be using it. It's cool. Now let's throw it all together. We've got our song. We've got our little targets being made. We've got our, let's see, overlay canvas. Just going to make sure that everything's applied. What's that plane? Oh yeah. Don't worry about that. Target, apply. Okay. Oh, that should be at 0. No overrides, beautiful. Overlay canvas, no overrides. Event system. I will do. I'm just gonna create a game manager. I know that we don't have a game manager script yet. I'm just gonna create a game manager file. I don't like this lifecycle event to be just wandering around. So I'll just call it game manager. Now I'm going to attach this event system. This is the event system used by UI, and lifecycle events just as children of that. And then what we're going to do is we're just going to create a prefab for the game manager. Okay. So they're already hooked up. This is a cool thing. This lifecycle events, because it's hooked up to a scriptable object, when we drag in prefabs, we don't need to do any of that sort of, connecting everything together. Now, back to our other scene. Sample scene. We'll just call this main. Okay, where were we at with this one? We've got our target generator, which has a target prefab, target destination. I'm going to go ahead and drag in our, let's see, we've got a few to drag in here. Prefabs, we drag in our game manager. We're going to need that. We're going to need our target smasher. We're going to need that. Target destination. I'm going to move the target destination just a little bit in front of the target smasher for now. I know the camera's a little bit whack. I'm going to move the camera as well just for demoing. -3 on the X and Y equals 2 maybe. And then rotate it down a bit. Okay, maybe a little bit forward. Alrighty. Okay. Listeners is never assigned to. Oh. Okay, yeah. Because I made those private. I just need to initialize these listeners every time that it's on enable. No, I really, because I don't know the order of these on enabled, I should just do this equals new list to pass. I want this to happen as soon as possible. And I just do it on awake, of course. New list. Okay. Again, I'm gonna, I'll fix all this up later. Make it more, so that we're not duplicating code everywhere. Anyway, that's fine. Okay, now where are we at? We've got our target smasher, which has a target smasher tag. Targets themselves are fine. We need the UI. Prefabs, overlay canvas, score NA. Okay, so let's just try. Yeah, what happens if we, I don't know where we're at in terms of what needs doing. I just want to see if we play what's working and what needs more work. Hit play. Score is 0, that's working. Oh, is this plane got, no? Nice. That's awesome. Okay. I'm gonna move that plane back. Move the move the, what is it called again? Target destination. I'll move that back to 0. And I'm going to disable the mesh renderer for now. So that it's hitting the cube on the beat, hitting the sphere on the beat. That's cool. Because their sizes are a bit different, we really need, this is very particular, right? But the radius of the sphere is, see, it's like a little bit early, right? The radius of the sphere is 0.3. The diameter of the, sorry, the total, I'll show rather than telling. It's easier. Okay, so our target has a collider width of 3, right? The collider size of 3, which means it's 0.15 to get to the center of the target. Now the same with the target smasher. It has a radius of it's got a radius of 0.15. So we want the point of collision to be 0.15 ahead of the target smasher. It's very particular, but it'll make a little difference. Okay, target destination said 0.15. Okay, so that they're meant to arrive at collision point on the beat. I think we got that right. Yeah, it's sort of there. It feels like it should be a little bit. Yeah, it's good enough. We're getting lots of points. All right. 2 more things I want to do. One of them is offset the positions depending on what type of beat it is, and the other is have a test, move around player controller. Okay, so let's go ahead and make that player controller really quick. Just utility. Just call it. Just call it player controller. Oh no, it's really a. I don't know, camera. No, object controller. Object controller. What is it called? The target smasher controller. Test controller. Okay. Beautiful. Update. Const x equals input dot get axis horizontal. Do vertical for the y. Oh, const. Whoops, that's so JavaScript. They're floats, so it should be specific. Okay, y, x and y. Okay, now let's see. Transform dot translate. Let's have a public float speed. Translate x times. Oh no, we'll make a translation. Vector 3 translation equals new vector 3 x y 0 times speed times time dot delta time. Translate by translation. All right. Now, just for demoing at the moment, I'm just going to go into the target generator, and in generate target, we're going to have an offset position. Vector 3 offset position. Okay, so then we, when we're instantiating it, so say var pos equals transform dot position, so wherever the target generator's position is, plus the offset position. Okay, pos quaternion dot identity and Python transform. Okay, so which means with the whole beat, maybe we want the whole beat to be like boom, boom, like down. So maybe we want it to be, let's see, vector 3 dot up times negative 0.5. So 50 centimeters down. Okay? And maybe every half beat, down, up, down, up. I won't be able to hit the half beat. Okay. Okay, so I'm gonna make a new one, right? If beat count plus, we're gonna make an off beat, right? So instead of whole beat, I'm gonna call this down beat. Down beat. So 1, 2, 3. Oh, wait. Down. No. Okay, that's the whole beat. I'm thinking of the half beat. I'm thinking of like down. Down is a half beat, and then there's a down beat and the up beat. Down, up, down, up, down, up, down, up, down, up, like that. So we sort of have a, you know what I mean? We have a downbeat. Downbeat whole would be boom, 2, 3, 4, boom, 2, 3, 4, and then upbeat whole would be like boom, 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 boom. I think that's making sense. So what I'm going to do is I'm just going to, like, this is all just mucking around at this point. I'm going to call this a down half beat handler. So that's every 2. Oh, look, nah. I really want it to be the whole. So down whole beat handler. And we'll simply say if, if beat count plus 1. Gosh. Alright, I'm just going to cheat. I don't think this is correct. I don't think this is the correct wording at all, but I don't care. I'm just going to use it like this for now. Down whole beat, and I'm just going to call this an up whole beat. So like 1, 2, 3. No, yeah, 1, 2, 3, 4. 1, 2, 3, 4. I don't know what it's called, but I'm just going to call it an up whole beat. So up whole beat will be 50 centimeters up. Okay, so that's an offset by 2 beats, by 2 quarter beats. That's going to get the up whole beat. Okay. I think that's everything. Let's have a look. Target smasher, target smash. Test controller with a speed of 1. Let's test that out. Oh. What's happening there? I think they're being generated at the same. Oh yeah, half beat handler. Just going to ignore the half beat handler for now. Okay. Oh, this is really hard angle. Alright, I'm going to move the camera a bit. And also I'm going to increase the speed a bit. Let's see, where's the camera? Yeah, it kind of needs a bit of context. It's sort of like floating in space at the moment. That's all right. It'll do for now. Gosh, that's hard. There we go. Oh. Man, I'm gonna play this for a while. It's quite fun. Yeah. Certainly. We need some like particle effects. It's strangely addictive, even just with the up down. Okay. Yeah. So that's pretty much everything. I kind of, you know what? I'm gonna finish this. I'm gonna finish this game. Cool. Cool. Awesome. So, that's coming along really well. One thing I want to quickly change is I know sometimes when the targets collided with the object, sometimes I'd collide twice. So we want to make sure the targets can only collide once. Let's see, so target mover, let's see, on collision enter. We'll just have let's see, I wonder if we can disable the collider. Component in children, collider dot set dot active. Yeah, I just want to make sure that they only, like, it kind of turns itself off once it gets hit. Yeah, I think I can just do this. Get component children, got collider dot game object dot set active false. Okay. I think that'll work. Okay, I just probably don't need the music. I'm just going to quickly, I'll disable the audio player, disable the audio source. What I'm going to do is I'm going to just see if it's going turn its collider off. Okay, so where's that first one? This first one. Okay, so the collider's not enabled, which means that I'm pretty sure that means that it won't be able to you won't be able to hit it twice. Anyway, that's everything. That's everything for today. I'm gonna put all this stuff up on GitHub soon. And yeah, there's plenty more to do here, and I'm quite excited about this project. It's a lot of fun. You end up having some music to dance to at the end. Cool, guys. See you later.